So, good afternoon, ladies and gentlemen. Thank you for being there for this second half day, the first afternoon of those Dauphine Digital Days. And this afternoon is organized by or in cooperation between Dauphine Digital and the chair, the Governance and Regulation chair at Dauphine University. We will be discussing this afternoon of the important question of the quality of data to develop AI systems. We all know that the quality of AI engines is critically depending on the quality of data that are used to train them. While there is, we know that on the other side of the Atlantic, there is much more computing capabilities and also a lot of money to develop those very, very large LLMs. The strategic reply by Europe, in a sense, has been to try to develop high-quality data spaces, and those high-quality data spaces can allow to train sometimes a large LLM, so to fine-tune the very large LLM, but sometimes to develop new type of AI engines trained for specific purpose, so those so-called vertical AI systems. But then, of course, this is a general vision of what needs to be done, because it's not so easy to share data. Even if you have common interest at the industrial level or at the European level, you have competitors in industry along value chains. You have a lot of issues related to the security of data, for instance, and so the governance of those data sharing ecosystem is critical. And basically, this is what we will discuss this afternoon. So the afternoon is organized in two sessions. The first session is really focused on the interplay between data sharing and the development of AI system, of vertical AI. Also, those vertical AI, it's important to highlight when you develop vertical AI, you can also combine machine learning and symbolic AI, in a sense, because you know you are in a known type of universe, and you have scientific backgrounds and knowledge that has been accumulated over time at the industry level. So you can combine those type of AI those methodology to develop AI engines. So in the first part of the afternoon, we'll really focus on this interplay between data sharing and AI, data sharing ecosystem and AI development. In the second part of the afternoon, we focus more on the development of sovereign AI systems. So, of course, there are a lot of relationship between the two. But this is basically how the debate is organized. So we'll have first, in a row, 4 presentations each time, starting by a kind of more extended presentation, and then 3 shorter presentations, and then we'll organize the Q&A and debate with the audience. Okay, so it's my pleasure this afternoon to welcome the 4 first panelists. So Jakob Rehof is a professor of computer science at the University of Dortmund, and is also the director of the Lamarr Institute. He exercised important responsibilities in the past in the Fraunhofer Institute, and he has a background, so he has a PhD in computer science, but he spent a part of his life in the US, and even working for the evil Microsoft for almost 10 years. So he knows what he is talking about, and I will go there. I mean, develop a bit when he will speak. He will speak of data sharing on vertical AI this afternoon. But before then, just let me announce the other speakers. So Emmanuel, Bacry, and I will spend more time to introduce them at each time they will take the floor. Emmanuel is research director at the CNRS and an eminent professor in Dauphine University. He's a member of the Prairie Institute, which is a large research cluster established in Paris, which is coordinated by INRIA and PSL. And he's also the scientific director of the Health Data Hub, and he will explain what the Health Data Hub is. Then we will have Hubert Tardieu, who is a member of the board of Gaia-X. Gaia-X is a European initiative, initially a Franco-German initiative among industrial corporations aimed at developing tools and but also governance mechanisms to supervise and promote the development of data sharing ecosystem in Europe, industry by industry. So you have the large, most of the large European corporation in this European association, which is working closely both with national governments or the governments of member states and the European Commission to develop various types of initiatives in Europe aimed at promoting vertical data sharing ecosystems. And then we'll have Tobias Guggenberger, who is a postdoc researcher at Dortmund University, and who has been working extensively on the governance of data sharing ecosystem. Tobias is currently very much involved in a European initiative promoting, in fact, data sharing ecosystem in Europe and assessing the development of the various ecosystems that are developing in Europe. And the second session will be introduced later by Joël, but we'll do that later, Joël, or do you want to? Yeah, I think it's better. Okay. Okay, so without further development, I give immediately the floor to Jakob. And Jakob, thank you very much for having having made it to Paris to give this talk. Thank you so much.
Well, thank you very much for inviting me, Éric. It's always a pleasure to be here. Let me see if I can get at my slides. If I continue here, they might turn up. Is that right?
Yeah, okay,
yes.
go ahead.
There we go. Okay. Well, thanks for inviting me. Always a pleasure to be here. So I will try in the next 30 minutes or so briefly to tell you why I think that the connection between data sharing and vertical AI is a real opportunity for European research and development. In fact, I think it is the main opportunity for research and development in Europe in the AI space. So before I get into that, let me just say a few words about the Lamarr Institute that Éric mentioned. It's one of the new 6 research centers in Germany established around 2022. And it is a joint center between the University of Dortmund and the University of Bonn. And it has 2 Fraunhofer institutes, the IML in Dortmund, which is Europe's, maybe the world's largest institute for research devoted to logistics, and the Fraunhofer IAIS, which is sort of the Fraunhofer Machine Learning and AI Institute. And so across those 2 places, Bonn and Dortmund, we now network certainly over 40 principal investigators, professors, and about, I guess now, some 150 to 200 PhD students and postdocs. So it's a large thing. The Lamarr Institute, its mission has from the outset been to complement AI in two dimensions. Of course, when you think about AI and machine learning in particular, of course, you think about data. Data is kind of the oil from which that whole operation burns. But complementing that with two further dimensions, namely sort of background knowledge or world knowledge, or more specific knowledge coming from vertical domains. So this is something that's closely related to the idea of verticalization, that is developing domain-specific AI and machine learning models. And then context pertaining to the context of use. For example, context might mean also taking into account the resource context. Sustainability is a real issue nowadays in the context of AI. So if you want to understand how this is organized briefly, I can show you this picture, which kind of suggests that there are two dimensions here. Our so-called key research areas, the ones shown on the top, they are kind of horizontal areas. They're like generic research areas that are kind of pertaining to the technical core of AI and machine learning. So hybrid machine learning studies how you can bring in various forms of formal knowledge, for example, in physics, how you can bring in that kind of knowledge into machine learning models. So, for example, in physics, it doesn't really make any sense to try to train a model to learn Einstein's relativity theory, right? Because we already worked for quite a while developing that, or let's say the Navier-Stokes equations. You don't have to try to teach a machine that. That would be very stupid. But so you have to, if you want to take advantage of that background knowledge, you have to somehow bring that into contact with the learning mechanism. How do you do that? So that's an interesting set of questions. Resource-aware machine learning has to do with trying to do machine learning being more efficient, for example. You can think of something like the DeepSeek development that we saw out of China recently, fantastic development, something called like model distillation. You take a big model, like a big LLM model, and then you try to distill that model, you try to make it smaller while retaining as much as possible of the functionality of the model. That's a very interesting, pervasive topic. Again, this is a topic that makes sense generally, horizontally across many applications. Trustworthiness is a horizontal topic, right? How do you make models trustworthy? This is a topic that makes sense in almost any application of machine learning. Human-centered AI systems have to do with how to kind of bridge the gap between human cognition and mechanical cognition, for example, by being able to represent the reasons why a machine learning model achieved its conclusions, or why it behaved the way it did, or think of representing large data sets in such a way that humans can understand them. Embodied AI, we're talking about robotics. So those were the kind of pervasive horizontal topics. Now, the lower line of pictures suggests the research topics that we're particularly engaged with of a vertical nature. So, for example, planning and logistics, I already mentioned that, is important. Physics is obviously a very vertical domain. This is very domain-specific, right? Industry and production is domain-specific. Life science is domain-specific. Life sciences and health. Natural language processing, you could actually discuss whether that belonged in the top line nowadays, because it's become so important in and pervasive in terms of the LLM development. But if you think of it specifically as applied to, for example, problems of language translation, then it makes sense maybe to think of it in a vertical way. So I'll give you very briefly a couple of examples taken from the work that this institute is doing and has done, illustrating the power of verticality in AI. And also what I want to make here is the point that actually vertical AI has already been playing a central role in science, engineering, and also to some extent in industry. But science is really the foremost example. Now here, the slide is not really coming across so well, but it doesn't matter. I can explain what it's supposed to say. So the example from physics I've taken here is an example that the Lamarr Institute was involved in over the past few years in the context of something called the IceCube project. The IceCube project is a physics project that's installed on the South Pole, where they have installed like huge rafts of ice, like a kilometer down in the ground in the ice in the South Pole. And why have they done that? Well, they've done it to create a kind of sensor that can sense neutrino radiation coming from the cosmos. And so it's a big problem in physics to understand where neutrinos come from. Neutrinos are very hard to study because they're very weakly interacting particles. So even understanding, for example, the direction from which a load of neutrino radiation came is very difficult. So here's what they did in the context of this project. They used physical theory. Physical theory was used to create a simulation model. Physical theory means some integral, some Fredholm integral. And you implement that, you construct a simulator out of that, and you then use that simulator to train a neural network to recognize a handful of signatures of interactions that the physical theory would predict to behave in a certain way under certain conditions. So this is all artificially trained, synthetically trained, based on physical theory. You train the network. Then in this project, by having, a very complicated system of sensors set up down there in the ice cube on the South Pole, has been gathering, petabytes and petabytes and petabytes of data over a period of 10 years. So much data, in fact, that of course no human being would know what to do with any of it. But now here's the point. This is the beautiful point. The pre-trained model, this physically, theoretically trained neural network, was let loose on the real data. And lo and behold, what came out was a fantastic picture of where neutrino radiation comes from in the Milky Way. And this result was a breakthrough in physics, and it was a result that was actually cited, it says there at page 9, in the 2024 Nobel Prize laudatio by the Swedish Academy. You may remember that the Physics Nobel Prize in 24 went to Hinton and Hopfield, two pioneers in the development of machine learning techniques. And so this was cited, this work there, because it was regarded as a foremost example of what you can do with machine learning in physics. Another example is taken from life science. You may also recall that a second Nobel Prize last year went to AlphaFold, a machine learning-based tool for analyzing protein folding. This particular example here, taken from the Lamarr Institute, is not using AlphaFold, but it's doing something that is also related in an interesting way to vertical AI, because the work here was about creating an LLM-style model for particular protein structures that could then be used to study how such structures behave, and also be used to discover such structures for example, for drug discovery purposes. The third example is taken from industry, sort of technical part of industry production, where a lot of work can be done and is being done to understand how various production tools interact with materials. So for example, here you have a machining tool that is maybe drilling or milling some physical material. You want to understand at a very fine-grained level, maybe even at a microscopic level, how the tool interacts with the physical matter, so that you can optimize production processes, for example, by better understanding which conditions lead to enhanced or decreased quality of the end product. And so what do? You place lots of sensors around the tool, around the material. You take in lots and lots and lots of data, and now you need to analyze these data. And in order to do that, you train a machine learning model, and that then helps you automate the process of understanding these questions that are important for optimizing these production processes. So here I wanted to say that if you look at scientific applications and also some of the technical applications in production systems, people have actually been using machine learning tech years for quite a while. I think physics is probably the best example. I mean, back before the revolution in 2015, if you want to talk about that year as a particular year, that's when we saw, AlphaZero produced a chess-playing game, and then shortly after that, AlphaGo came along, and then 2017, we saw the transformer models. Those years kind of are markers for the ongoing revolution in the field. But even before that, if you talk to physicists who work at CERN, having to do with these large, humongous sets of data that they gather, for example, around the Large Hadron Collider there, they've been throwing neural network technology at data analysis down there for quite a while. And so we know a lot about these kinds of vertical, specialized, domain-specific applications. And so, of course, this allows us from a European perspective to tap into the strengths that we have in those areas, right? So Europe has a fantastic research system, and it has a very significant system of technical production, for example, and so we can tap into that. And that's the way we need to think about moving ahead in the AI area, because we're not going to be able to, I think, compete directly with the Americans, you mentioned it before, when it comes to these horizontal, generic, very, very large and very, very expensive platforms like you find at Microsoft, Meta, Google, or Amazon. In some sense, that race that's an American game. The European game is to try to put mind over matter, to put mathematics over hardware, to think and to be better at that, and to marry that with AI technology. That also will need some hardware investments, but our value creation cannot primarily come from the pure hardware muscle. It must come from this one up here. And in order to do that, we need to be able to share data. And in the context of data sharing, in particular, in order to bring this vertical AI idea further into industrial practice, it's important that we organize ecosystems for data sharing, like we find in Gaia-X and in international data spaces projects in Europe that have become important for sharing data among organizations and industrial companies. And so data spaces are important for data sharing, and data sharing is important for vertical AI. That's the takeaway here. Now on this slide, which I borrowed with Hubert's permission, there are a few points I want to make of a more sort of computer science technical nature in terms of some topics that are recognized as important for vertical AI. So you can see up there in the top left section, common domain ontologies. That means we need to be able to share some abstract understanding of what the shared information means. How do we interpret the information that we share? If I tell you my name and my address, there's 100 different ways I can do that. So we need to agree on how you interpret that string, which I'm going to send to you. And if I send you some, enormous set of physical data so that you might be able to use it in some context. You need to know how to interpret it. So we need some sort of shared models, information models, and that's what meant by common domain ontologies up there. Now, if we can share data, then we can use that shared data to fine-tune models for vertical purposes. That means like creating, for example, an LLM that is not about general language recognition, but now maybe it's about recognizing protein structure, because it turns out protein structures have kind of linguistic structures. And so it makes sense to try to do that, like I showed in my example before. So that's called fine-tuning. That means that you're really trying to specialize a model in a deep way by imbuing it with highly specific data. But there are further topics that are important. Retrieval augmented generation, or RAG processes, as you see there, is the idea of augmenting, for example, a model like an LLM, like a large language model, augmenting it by providing contextual information, for example, in the form of specific documents that pertain to the vertical specific application that you're interested in now. So if, for example, I want my model to give me legal advice, well, it might have to have direct access and be directed towards relevant legal documents that can be provided so that the context of answering these questions becomes less hallucinatory and more focused on the domain. So there's a lot of work going on also in machine learning studies about how to organize such RAG processes. And the final topic I want to point out here from this slide in the more technical vein is agentic tools down there in the lower left part. That means it talks about the necessity of wrapping these machine learning techniques in larger software systems that make these techniques accessible to domain experts. So, for example, creating connections between specific workflow processes in a particular domain. Let's say I want to use, for example, machine learning in a clinical context. Then I need to be able to make it easy for people working in the clinic to actually get at the information that might be produced by these machine learning models. And that process of doing so, it needs to be integrated into the work processes of the clinical people, and it needs to be automated as much as possible. So we talk about AI agents when we talk about software systems of various kinds that take advantage of AI models to help automate particular kinds of vertical processes. So here's another slide that I'm sure Hubert might also maybe comment on, but this shows again how data spaces like Gaia-X and international data spaces are important for facilitating trustworthy and secure, and we would say also, sovereign use of data. And so this is necessary. This is part of the whole system that is offered by these data spaces, is the governmental structures, the policy structures, and the organizational structures that are needed in order for trust to arise between different parties so that they become interested in sharing data and using data provided by other parties. And here's a picture which I'm not going to go into in a lot of detail in the interest of time. Again, this is one I borrowed from Hubert and his colleagues. One thing I wanted to point out here is on the top part of this picture, you can sort of see that there's a kind of a pipeline where on the left you're talking about basic AI models that then through fine-tuning become sector-specific AI models for some particular industry sector, for example, or for some particular scientific application area like physics. And then through further fine-tuning, it could even become a company-specific AI model. So that shows you kind of a pipeline there. And of course, it's now a very interesting and possibly also quite difficult topic to start talking about, well, what if those basic AI models are completely generic models that are made, let's say, outside of our own control? Let's say they are generic American models. Some of the most powerful generic models today, if you talk about large language models, are in fact models that you find created by some of the large American hyperscalers. So how is it possible to kind of take advantage of those foundation models in the context of data sharing, where we want to fine-tune such models and use them in a trusted way in a data ecosystem? This is some of the problems that need to be studied here. Another thing, and the last thing I want to pick out from this slide, is sort of the keyword reasoning that appears in several places up here. For example, you got in sector-specific AI models, you get domain-specific reasoning data. And so this is the necessity of augmenting machine learning. Purely statistical models typically need, when the game gets serious about verticalization, you typically need to augment these purely statistical models with some sort of old-fashioned logical AI. Comes back into the game. It comes back into the game at these points. I mean, if you want to reason about, let's say, physics, you need some sort of physical logic that knows what kinds of conclusions you can draw from certain data together with certain, let's say, differential equations. There's a huge amount of physical knowledge there, but that needs to be also put into so-called trains of thought, that is, chains of reasoning. So what statistical models typically are not so good at is creating kind of chains of thought in terms of sort of logical reasoning processes. And so old-fashioned logical AI comes back with a revenge here, and there's a lot of interesting questions to be studied there. So let me just now very briefly point to some research problems and also opportunities that this idea of vertical AI in the context of data sharing may bring out. So as I like to say that, it's the privilege of research to be able to consider problems as opportunities. And I really also mean that, because value creation only can arise if you find some interesting problem to solve and you're better at solving it than others, then value can arise. And if you then manage to also put that in some productive context, then that's an interesting idea. Here, again, a picture of mine has fallen out, but no matter. You might think this is surprising, I at least do. It turns out that machine learning research has not really done much about learning from tabular data. Tabular data are data presented in the form of tables, like you find in databases. And so when you present data like that, you know a lot about the specific format of the data. For example, you know this is a name, this is an address, this is an identifier, this is a number, and so on and so forth. You're not talking about free-floating text like you have in the internet, such as has been used to train the large language models that we find, for example, in Microsoft or coming out of some of the American companies. In contrast, we're talking about highly structured data. This is important for the verticalization, because in vertical AI, that's the kind of data we want to use. And now it turns out that people are starting to find out in machine learning that you can do things with tabular data which you could not do with just free-floating, freestyle textual data. And in this particular line of work called pave, which stands for prior data. Let me just get the acronym right. It stands for Tabular Prior Data Fitted Network, pave. That's a new technique. It's about 2 years old, and some of the people in my institute is taking part in developing it. That's why one of the reasons I bring in this example here. It turns out that you can do things with tabular data that you could not do with just freestyle data, which speeds up the learning process and increases the quality of the results you get on those data. So that's super interesting from this perspective. Federated learning is about how do you create systems that sort of can learn in a distributed way, where you have heterogeneous data sets. You're not talking about learning in parallel from the same data sets across many different computers. That's just distributing the learning process onto a bunch of computers in parallel. No, we're talking about learning from different sets of data pertaining maybe to the same vertical, right? So an example of that actually you find again in clinical applications. Let's say you want to bring together data sets from 100 hospitals, okay, in, let's say, some subfield of radiology. This is a very real example. And of course, if you could do that, you can gain. Because if you can bring together the data from 100 hospitals, well, you might create value that you could not do from just a single hospital. So now the task is to learn from those 100 different pools of data. But in this context, it's going to be very important that you do that without violating privacy concerns. So typically, the data residing in one of those hospitals needs to somehow stay private to that hospital. It cannot just be published into this pool. And how do you make sure that after training such a model that you can't reconstruct sensitive data from each of those data sources? Then you'd be in violation of important privacy concerns. So that's a huge issue, and research that can move that forward, I think, is going to be important in the context of AI ecosystems. Now, AI ecosystems, if we think that radically, it's not just a data sharing ecosystem anymore. Now it's a data sharing ecosystem that is also learning as an ecosystem. And in particular, in that context, I think it's important to think about this question: what are we going to do about hardware in Europe? Now, as you may have heard, the EU system is enabling fairly significant investments in hardware specialized for machine learning purposes, like farms of NVIDIA chips, which are very, very expensive. And as Éric already pointed out, nobody thinks that we'll be able to compete with the levels of American investments, which are also in some sense pretty crazy. I mean, NVIDIA now has a market cap of, it's a completely crazy number, and people are talking about a bubble building up and stuff like that. But here's the point. The point is, even though we put mind over matter, mathematics over hardware, we're still going to have to ramp up on the hardware level. If we fall too far back on that level, if we fall orders of magnitude below, we will not be able to keep up competition. And so there needs to be some investment. But we will not have in Europe any single entity powerful, economically powerful enough to do it by itself. So we have to pool the resources. Now we have these gigafactories and AI factories invested in by EU arising in various parts of Europe. my claim is these clusters need to be able to work together. And how do we organize that? And my plaidoyer here is to start thinking about hardware ecosystems that take some inspiration from our data ecosystems. That in some sense, that idea of creating sharing ecosystems need to be also now thought at the hardware level. And my last example now before ending of an interesting challenge for research and development arising in this context is something that's close to my own heart very much, which is about trying to automate or help automate data interoperability. I was talking about before, if you have data sharing, if you want to do data sharing, you need to have some agreed upon ways of interpreting the data, which may be represented in many, many different ways, coming from different sources. So how do you kind of align those different representations? And one, I think, very exciting idea here is to try to use generative AI technology to try to solve this problem automatically or more automatically as is possible today by namely, for example, generating code automatically that can transform between different representations of the same information, or that is able to map given data sets coming from a vertical domain and map it into some shared abstract information model, being automatically able to discover, oh, this string over here is actually what is called an address in the data model. This number here is actually what is called an ID in the abstract data model. If you have to create all these mappings by hand, it's too complicated, too costly, and the plane won't get off the ground. And so I really like this picture here, this virtual circle, as I call it. I presented it back in September in this very room, is the idea of saying that you could start with the idea from the Bacry report of using data sharing for AI in the form of vertical AI. So you use shared data to train AI models. But in the vein of this topic here, you could also try to use AI to enable data sharing, namely use generative AI models to solve the data interoperability problem and use AI technology inside data sharing agents, data sharing software agents that enable the data sharing. And if you can get this circle, this loop rolling, you have a positive feedback loop, and then you get a spiral, and then we're going to be fine. And this is actually now the Gaia X presentation of that loop you see to the right. This very last slide here shows you also a little bit about what I was mentioning, namely, you need to probably distinguish between two kinds of scenarios. One, to the left, you got a horizontal LLM there, a horizontal foundation model based on untrusted data. That might be a model coming from outside of the ecosystem. Now, how do you integrate that into a data sharing ecosystem that needs to work with specific forms of trust? A stronger situation you get to the right, which is more like my circle from before maybe, where sort of everything happens inside the ecosystem, and you can talk about trusted data coming from below, feeding into that circle. And so with that, I hope to have given you a few ideas about why vertical AI is important and why it is a particularly European project, which we absolutely need to get flying at this point. Thank you.
Thank you very much. So thank you very much, Jakob. In the interest of time, I will immediately give the floor to Emmanuel Bacry. So Emmanuel Bacry has a PhD in mathematics, the other important disciplines to develop AI system. And he has been involved in several initiatives both in the context of PSL and Prairie, I mentioned before, but also in the context of École Polytechnique and the CNAM. He has been developing several initiatives to promote and to teach and to develop research in AI. He is currently, as I mentioned before, the scientific director of the Health Data Hub. And he will, and so the Health Data Hub is typically a type of cooperation between the profession and research in healthcare. And you have, of course, it's done at the French level, but there are also initiatives in Europe. And so, Emmanuel, the floor is yours.
Thank you very much. Thank you. Thank you, Jakob, for all this great introduction. So you opened many doors, so it's hard. Okay, I'm not going to talk about all what you've talked, but yeah, so I'm going to, so I'm sorry, I don't have any slides. So I'm sorry for these, the people behind me. So I'll be talking about the vertical. I'll be talking about health. I like health, okay, of course, because, I mean, this is important, right? But also because when we're talking about AI, this is a major application of AI with a lot of promises, with potentially a lot of impact on public health, a lot of impact for all of us. But it is also a very sensitive application. So it's nice because whenever you have you might identify some problems with AI, you can be sure you find it on health. Okay, so it's a very good use case to talk about health because you identify so many problems also. And I'll be talking about that, of course. So first, very quickly, let me talk about promises or things that are already deployed today. So there are many, so I'm not going to do a huge list, right? I will just select a few of them. Of course, we already use AI for diagnostic aid. To take just one example, which is very well known, reading reading mammography for breast cancer. So you know that generally there are two readings, first reading by a junior radiologist and then another reading by a senior radiologist. The first reading now, we have AI that are doing that pretty well. So that's nice, but on the other part, it's not that nice because then we have a problem with education of the junior radiologist. I mean, it was a very important part for them to get trained on this first reading. So there is a major issue about education by replacing junior radiologists with AI, but it is working pretty well today. Prevention, again, breast cancer. This is something that people have tried with AI, and it works kind of pretty well also. And this is something that radiologists are not able to do, is trying to predict whether there will be a cancer. And now we have data of women mammographies that didn't have a cancer, and we just follow them, and we know they had 5 years later. So we train AI to try to guess whether there is, or to have a probability, a risk of cancer within 5 years. If we feel like there is a high probability, then the mammography will be done more regularly and stuff like that. So this is a very important application, of course. Personalized and precision medicine. So this is a huge application. Basically, it is about trying to find the right drugs and the right healthcare pathway for you and your pathology, but for you with all the characteristics of all what you are. And not saying we give you these drugs and this health, or you follow this healthcare pathway because this is the healthcare pathway of this pathology for anybody, right? We are trying to focus on who you are. This is already deployed on oncology, looking at the genetic characteristics of the tumor. So this is something that is already done. We can talk about public health, of course, also. And pharmacovigilance and pharmacoepidemiology. So we have these huge databases, and we have one in France, which is very nice, and that is extremely useful for that, which is the Carte Vitale database, right? That covers 68 million, I think now, people in France. And we are very lucky in France because almost everybody is reimbursed partially of almost everything. So we have a footprint of all the healthcare pathways of everybody, and this is very useful for detecting drugs that are on the market that have bad secondary effects. Okay, so that was the case of the Mediator, if you heard about it. But on the COVID, also there were a lot of studies that were among the biggest studies made all over the world. Generative AI has a lot of applications too, even helping doctors in the diagnostic aid, so doing a brainstorming, but keeping in mind that LLMs have no notion of truth, right? So this is also very, very important, that you should always be aware that whatever comes out from an LLM could be totally wrong. But it's a good brainstorming tool, and it can be used for that. For gaining time also, of course, for writing the reports, this is already deployed everywhere, I guess, in France. And then you mentioned AlphaFold and drug design, drug discovery. This is a major application, clearly a major application. And there is another one about virtual control arms for clinical trials. So this is also to accelerate clinical research. So there are many parts, I'm not going to go over all of them, but many parts of the clinical research where AI could help. So these are the promises. Let me tell you a little bit very quickly about the problems also, of course, because there are so many. The black box problem is, of course, extremely important for health. Let me tell you one story. Chestnut, it was a deep learning algorithm that was extremely successful. Everybody talked about it. It was, I don't know, maybe 7 years ago, something like that, to detect pneumonia. And 1 year later, people showed that actually the deep learning algorithm was looking, so it was detecting pneumonia from X-ray. It was looking at the corners of the X-ray where the hospital was coded and the types of machine was coded. And some hospitals received some patients that were more sick than other hospitals, and he was just detecting pneumonia from that. Okay, so the black box, knowing what the AI is doing is extremely important, right? Biases and biases from the data. So I told you about this big database that we have in France, the Carte Vitale. This is very nice. If you compare in terms of size, the US databases that are comparable, you would look at insurance companies, right? But so you would reach, I don't know, maybe 20 million people in the biggest insurance company in the US. Now you have a major issue is that in the US insurance company, basically people are rich, young, and in good health. So this is a major bias, okay? Now, all data are biased, of course. In this Carte Vitale, we have many French people. This is a bias. Okay, so, but it is less biased. So this is always something that we have in mind when we're doing AI. Are my data biased or not? This is a major issue. And, oh yeah, about bias, let me just put some punchline. We can discuss about it during the question. We are today developing mainly an Occidental AI, right? And especially in health. Most databases in health are about male, white people, Occidental people. So this is an issue. Another, male, there are less women. In historical health databases, there are much less women than men. Yeah. This is a well-known thing. One thing that we don't talk that much, there is a lot of research about that. It's what we call hidden features. Let me give you one story. There is a paper that came, I think that was released about a year ago. They proved that from a chest X-ray, they trained an AI, and it's pretty successful, to find the ethnic origin of the person and the level of wealth of the person. Okay? So they played this game because in your mind, of course, you have the fact that if you train an AI to discover a pathology, maybe it will use this to discover the pathology, and so there will be a bias, and maybe you can have many issues because of that, right? And last but not least, evaluation. Evaluation of AI. The AI, when you deploy it, most of the time, and in health, almost always, it is deployed in a process chain with human people. right? You have, I mean, ideally, we would like to evaluate the whole system. Okay, and not just evaluate as you see in all the papers, because I mean, that's what we can do easily, of course, so I'm not blaming them. But in the papers, when you are looking at the AI algorithms, they say, okay, look at the precision I have, this is crazy, it's much better than the other one, so on. We just focus on precision. When you go in real life, this is like totally ridiculous most of the time, and the margin, because of the human involvement, is like, can be totally different. Let me tell you one story. And an AI was deployed for alerting for severe kidney failure in the reanimation services on 6 hospitals. And they did a randomization test, so that was good. It took 6,000 people, 3,000 with the alert, 3,000 without the alert, right? With the alert, in 2 of the hospitals, there was twice as much death, okay, with the AI deployed. They didn't really understand why. There is no clear reason, but it is clearly in the way the humans are using the AI information. When you put, there are plenty of studies, when you put a radiologist with an AI, whether it's a junior, a senior, whether it can be totally different, the impact you have, and this is something very, very important to evaluate. Let me go now to data, right? So, as you said, and I'm a big fan of data. I think the whole, I mean, most of the revolution of AI that we're talking about and in health, but in other verticals, is about the revolution of data, most of it. Of course, there is a part which is new methodologies and stuff like that, but there is it's so important data. And I'm used to talk about revolution of data, and I would just name 3 items that I think are kind of universals to almost all verticals, and you mentioned a few of them, of course, I mean, almost all of them, but I would like to rephrase them. The first one is about fragmentation of data. It's the fact that it's very hard to understand where the data is. It's stupid, but it's extremely important. Where is what kind of data? I'm saying these are universal, not only because they are the same for all of the verticals, but I can tell you I helped big industries in numerical transition. I work with institutions. I work at the national level, European level. These problems are the same everywhere, okay? So fragmentation of data. Second problem, which is huge, it's governance. It's a huge problem, right? And when we are talking about health data, it can be a nightmare. And it's not, we don't blame France. I mean, everybody has the same problems, right, in the world. It's not a French problem or European problems. You can wait for a long time to try to have access to data, and then also you have all these data holders that feel like this is their own, right? And this is, this is gold, and they shouldn't give it to you, and it can be really, really a problem. Just let me mention what happened during the COVID crisis, because I was involved at the national level to facilitate access to data at this level. I can tell you that this ownership feeling that keeps people from sharing data, I'm talking about institutions, private companies, researchers, and so on, it was horrible during COVID. It was 10 times more stronger than as usual. And we needed it so much. This was such a paradox that was totally crazy. Just because there was a valorization problem, scientific valorization and financial valorization. This is a major issue. And third and last problem of this revolution of data, you mentioned it in your last slide, is interoperability. Now, you addressed some aspects of interoperability. Some of them, you cannot solve it automatically at all. There is no way you will be able to solve it. Let me give you, again, a COVID example during the same experience I had. We all know, I mean, it's not that brilliant idea to know that to follow the dynamic of a pandemic, you need to look at the data of the emergency services, right? So I tried at the beginning of COVID to say to all the emergency services in France, okay, let's gather all the data so that we can follow the dynamics of COVID. Now we had one major issue. All emergency services were coding COVID differently because there was no PCR test, not enough. So some of the emergency services, they would say, I code COVID only when I did the test because otherwise I don't know. Some of them said, no, when I see this symptom and this symptom, I code COVID and so on. So they were all discussing, they were all coding a different pathology. So you can put everything together, you can ask an LLM to solve the problem. There is no way to solve this problem. Same thing with rare diseases. When very, very rare diseases, if you don't have the same definition as your neighbor, you cannot do anything with the data, right? Even if you collect them. So this is a major issue. These are the three major issues. It's not the good news that revolution of data is the main thing because it's so hard to operate, so hard to operate. So at the Health Data Hub, we bring a small break to that thing, and I think we are doing a good job. We are supporting 250 projects, I think, with many types of data, many types of problematics, many types of actors, big industries, startups, academics, and so on. And I think this is very important. Let me now, and I'll be over after that, let me tell you about a very unique initiative in Europe that is called the European Health Data Space. So I don't know if you heard about it. It was voted more or less at the same time as the AI Act. And basically this space, this regulation, so it's a new regulation that is being deployed now, is about trying to solve this data revolution. So there are two aspects. There is a primary use of data. I'm not going to talk about that. I was only talking about secondary use, right? Research. And there is this secondary use. So what are the main, I would say, punchlines of this law? They are extremely punchy. It's a very, very punchy, and so it could be a little scary in terms of, you know, when we hear about AI Act, everybody's scary about saying, okay, it's going to kill innovation and stuff like that. So about the European Health Data Space, we could also be a little bit afraid of that. But let me give you a few examples of what this law states. First thing, all health data, whether it is produced by private industries or public institutions, are required to be shared for public interest research. Okay, so this is huge. We are talking about everything. All the medical devices, all the clinical trials data, genetic data, any form of data, they will all be required to be shared for public interest research. And public interest research is a very wide concept, right? That can, of course, be used by private companies and by industries. So this is one thing. Second thing, it will give prices to access the data. It will give grid, so wide grids, but still, it will give tarifications to access the data. And there is one main principle that is very, very touchy that says that you cannot make money out of giving access to data. So you can reimburse the cost, but you cannot make a business of giving access to data. So that's a second thing. And last but not least, it sets some maximum delay to have an access, to get the access to the data. So basically, as a user to this European Health Data Space, if you want to do some research, you will connect to a central portal where you will be able to run some queries on the metadata of all the data available on all the member states. So in each member state, you'll have a health data access body. So there will be one in France who will play, well, there is nothing official, but basically the hub will be part of that, of course. And so you will be able to see what is available. So that's the fragmentation of data that I was talking about, the problem. Then you will be able to fill up a unique form for all the different databases on all the different countries. This is going to be a nightmare to deploy, right? But that's the goal. And then you upload the form. Then each of the health data access body will have a maximum of 4 months to answer you with a yes and or no. If you have a yes, it's a maximum of 4 months again to have access to the data. If the data producer doesn't give access within 4 months, he has a fine. Right? So that's 4 months plus 4 months, that's 8 months. Believe me, this is short. This is very short. Okay? So this is a unique initiative. I'm not at all 100% sure that it will work, but this is extremely unique. There is no other countries or other group of countries that is doing that at such a level. And there is one thing which is, and I will be finished after that, one thing that is at least nice is that at the beginning of the hub, I was organizing a lot of delegation all over the place in the world. So we went to see Japan and so on, and all the countries, and trying to, to do connection. And now we don't move. It's like you have this US block and you have the China block, and then all the other countries now they hear about the Europe, and when they hear about Europe, they see France because we are kind of a leader platform to that, and they call us and they come to see us. We had the delegation of 30 people from Taiwan from the Ministry of Health. We have the delegation of South Korea. We have delegation. So it's like everybody hear about that. They feel like something is happening. It is going to be extremely challenging to make it happen, but I hope it will succeed. Thank you very much.
Thank you very much, Emmanuel. Very stimulating and interesting and promising, and also good luck with the with the process of European coordination. Now let me give the floor to Hubert Tardieu. So Hubert is not an academic, even if he has written extensively in the domain of computer science, information system, etc., etc. He has been working with the industry for 27 years or so, in corporations like CEMA, Schlumberger, and then Atos. He was the advisor of Atos CEO, a certain Thierry Breton, who became then, as many of you know, but some others probably don't know because they are young and from abroad. He became a French Minister of Industry and a European Commissioner. And that's probably why Hubert is very much involved in this initiative I mentioned before, which is the Gaia-X initiative, which is a very large non-for-profit organization, association, as we say in France, in French, grouping together many corporations in Europe, but also working closely with member state governments and with the European Commission to stimulate the development of data sharing ecosystem. And Hubert was the CEO of Gaia-X for a while. He was the chairman of the board of Gaia-X, and now he's still in a board member responsible for the relationship with governments. And Hubert, the floor is yours to explain us what is the season 2 of data spaces in Europe.
Thank you, Éric. So I think I will follow basically what Jakob has said and what Emmanuel has said. So I am positioning what I will present to you, how to prepare the advent of vertical AI, which is suggested by the Draghi report. But I am not in the context Emmanuel was describing, where you cannot make any money out of the data you want to use. I am in a context where some of those data space need to have their own economical viability if they want to survive. And I have been taking the presentation as it was in the title of this conference by saying the competitive advantage of Europe for AI are the data spaces, meaning that it is all about data. So for that, I'll try to go quickly because I do not have that much time. Why do we need to continue to make an effort about data spaces? The what, and I would say Jakob has already very much explained how data spaces and AI will be connected together. And I will insist at the end about the how, because nothing will happen if we do not have a massive investment which is done both at national level and European level. So, yeah, thank you. So my first point is about the why data spaces in the European data union. Today, where do we stand? We do have a data space reference architecture. We have blueprint for EU Data Space Support Center, and Tobias will speak about that. We do have a large international manufacturing X community established, and as always, when you are in that kind of business, you are looking for creating standards. So 2 standards are in preparation, one on trusted transaction, another one about the overall data spaces, Sensenelec and ISO. It is important to say that data spaces have been established already in 3 major domains. It started in Germany with automotive, with the project called Catena X, but recently, France, at the beginning of this year, has decided to support very strongly 2 important data spaces, one in aeronautics and one in nuclear. As you probably know, these are 2 domains. In aeronautics, no dispute, Europe is #1 in the world. In nuclear, France is in the top 3. So what is important is to explain why establishing a data space can keep us in a very important position. So I would say there have been several things which have been done. I don't want to get into it. And Emmanuel was mentioning the governance issue. What we have decided is to have some label to define how data sharing will be done, and it will be done through clearinghouse to check, not having civil servant to do it, whether automating the compliance to see whether it is respected properly. Now, let me tell you, after 4 years, not everything is okay, because many productive data ecosystems are lacking viable business model or suffering from slow adoption. And in that respect, I would like to thank Dauphine, Chair of Governance and Regulation, which has been helping Gaia-X for 3 years to establish something which seems to be pretty obvious. You should not subsidize a data space if you have no clue what are the use cases they will be using, and if you have no clue when and how they will become viable. There is no point preparing all kinds of data spaces in many domains if at the very minute the subsidies are stopping, the data space is collapsing, okay? So basically, what I would like to say, we have been working on that. We have now established, thanks to the work of Dauphine, what are the trajectory which are likely to deliver viable ecosystem. What I would like to say, we know how to make working some of them. We are not in a position to answer in any case. And we will have, at the end of the week, what we have called the economic theater, where Joël and Luca will welcome 10 projects, several of them in health. Some of them are saying they believe they can be viable after the end of their funding. So typically, if you look at this time, we are moving from what we have called the foundation stage, ecosystem formation, technology stack, feasibility and pilot, investment phase. This is over. We cannot continue to subsidize projects in France, in Germany, at European level, if we do not have a picture of the trajectory. So what is the ecosystem growth? What is the business viability? What are the networks effect on economy of scale? And how will we be able to return on investment phase? Last Friday, we were having what we are calling our governmental advisory board, regrouping 10 countries at pretty high level, people reporting to the minister, and they are now all agreeing that we cannot continue to subsidize data space if we have no clue about the economic viability. It took 3 years to reach that. What does it mean? We are, I don't want to get into everything of that, but it is a complete change of attitude, a complete change of mentality. Now, let me say, we need to have a continuous support, but as opposed to last 4 years, this support will not be given without that kind of certainty. Why do we need that? We need to give the response to the Draghi call for vertical AI. You may remember that Mario Draghi has suggested 10 different domains where we need vertical AI. Definitely the one we have, automotive, aeronautics, and nuclear are part of that. But there are others which are not covered at all at this point of time. And if we do not find a way to make them viable in the next 3 years, we have an issue. I would like to say that looking at this problem, which is always a problem how to properly spend the money of citizens, there have been two attitudes which are really interesting to illustrate. In France, we have said every project, and there is a significant call for tender which is driven by BPI, we have said any project coming which is not able to show a 36 return on investment, meaning viability after 36 months, will be discarded. Interestingly enough, it was not what happened in Germany. Germany decided to put a huge amount of money on Catena X, 200 million euro, to say the least, okay? And they have said that at the beginning, they will go for prioritization of use cases on regulation use case, typically carbon footprint or digital product passport. I would say anyone is obliged to do it, therefore they will do it. I would say it's not exactly the same way in France because aeronautics and nuclear, when they create aircraft and nuclear plant, they need to build together an object, and it is not simply doing together this kind of regulation. What is important to say, and we have a representative here of that, what we have understood, and thanks to the support of Dauphine, we do have two different markets. One which is a market of the user community willing to exchange data at a price which is reasonable for them. But you need next to that to have what we call data sharing intermediaries which are able to take those data which are in each cloud by users and to prepare the data sharing at a cost which is acceptable. And let me tell you, this has been also a difference of attitude between Germany and France. Germany has put a lot of money in their intermediary. To an extent, now, they are having some difficulties to make the economic viability of the intermediary, and they are trying to extend the reach from automotive to chemical. So you understand a very complex challenge, which is still now in front of us. Now, the what, I would like simply to show you that, and I will go quickly because Jakob has very well explained that. You see here, Bundesministerium für Wirtschaft und Energie. The German government is pushing for what they call an IPCEI, which is a very large project which is driven by at least 4 European countries and blessed by the European Commission. And their objective is to try to marry those 3 nodes in the triangle: infrastructure, foundation model, and data collection, data ecosystem. What Jakob has extremely well explained, in terms of infrastructure, we will be behind as compared to the US. We could be pretty good in foundation model, especially in terms of open source foundation model. But what we want at any expense is to make sure that in the next 3 to 4 years, for the main domains, we have viable economically data spaces ready to be used in each of the vertical AI. So this one was presented already by Jakob. What I want to tell you, we are exactly at this point where Germany and France have said, yes, we want to work on that. European Commission has said, why not? But we need in the next 6 months to try to regroup those intentions to make it a real project. So that thing has been presented by Jakob. This is where AI and data space are coming together. So we know there is a lot of work to be done there. I don't want to repeat what he has said. We know as well that data space are absolutely key for vertical AI ecosystem in terms of data sovereignty, improved data quality. I don't want to get into the detail of that. Let me now take the rest of my presentation to explain the how. That will be quick. We need to go from a follower strategy into a leading edge position. You may think it's impossible. I strongly believe it is still possible because of the competitive advantage of Europe in terms of data sharing. So what does it mean? We need to have viable business model, perform regular health check, develop and apply business model for different types of ecosystem. As you can understand, when Airbus or EDF is launching a data space, they do have deep pocket and they can sort out some problems. When you have, as it was the case last year, we have had a data space in agriculture, which finally collapsed, because when you have only farmers and you have no tractor manufacturer, you do not have anyone with deep pocket, and finally, AgData Hub was bankrupted, and we have learned a lot of that. Scaling adoption, as well, increase data readiness, establish cross-ecosystem governance. This is what Emmanuel was explaining. And ultimately, vertical AI, use AI to develop ontologies as we go. It was a data interoperability thing that Jakob has mentioned. Just to tell you, the very fact we rush on the viability, economic viability of data space means we develop application by use case, and we finish after 36 months with data definition which are local to each use case. And this is one of the major tasks that Lamarr Institute and ANITI have started with Airbus, which is to try to build afterwards the ontology as we go. Okay? And data and AI economy is also extremely important. So to finish up, the challenge we have in the next 6 months, really 6 months, is to make sure that the policymakers, and namely at least 4 major governments in Europe, plus European Commission, agree on the scheme I am presenting to you, I would say I am some kind of devastated when I see some call for tender coming from the European Commission asking at the deliverable after 3 years is a list of use cases, okay? It's over, it's finished. Now we need to have real things working, not interested to have a list of use cases. In terms of AI, and we know now pretty well how it works because we will have the experience of aeronautics and nuclear. The biggest possible problem we have now is making sure that SMEs are joining the data space. As you probably understand, SMEs are the one most of the time generating the data. Sometimes they are not technically mature enough to share their data. Sometimes they are very careful that big guys are eating their lunch in terms of data definition, typically. And so today, I have to tell you, and I would like to keep you this element in your mind, the objective in the data space for EDF is to have only 20% of the SMEs being connected after the 3 years. You may think it's bad, but this is the best they believe they have to do. So when you have sorted out everything in terms of ontology, economic, and so on, if you do not have the adhesion of the SME, forget it. Okay? And finally, this idea of being able to deliver a robust ecosystem after 3 years is becoming well accepted by many of the European countries, and we believe this is the way forward from now on. Thank you.
Thank you very much, Hubert. And now let's switch to Tobias Guggenberger. So Tobias is a postdoctoral researcher and the group lead for data space concept at the Fraunhofer Institute. He's also the deputy coordinator of an important initiative, which is the Data Space Support Center, DSSC, which is helping and assessing, in fact, the development of data space across Europe. And so through this position, he has been able to observe and measure the impact of the development of those data space in various contexts, in various supply chains, for instance, in various public-private ecosystems. And Tobias, the floor is yours.
Yeah, thank you, Éric, and all the other wonderful speakers that introduced the topic. So I can skip a few slides. So my my keynote today has the title "Why I Need Data Spaces," and Europe needs both. And I would like today to go over a couple of ideas that I, as Éric perfectly said, observed over the time that I worked in the European context and wrote papers also on that in a scientific context, and helped also organizations and ecosystems to further develop and build the foundations. So in that sense, I will start with the strategic context on my topic. So where are we now and what are the obstacles that I define as a structural problem of the current European digital economy. Then I explain again why data spaces and AI are perfectly working together to support Europe. And finally, I also lay down my vision. Yeah, this is a little bit broken, I see. No, I mean the graphics and stuff, but in any case. So first slide. And I'm sorry, but it's a little bit broken, so there are some strange signs on the left side. So first, from a general perspective, so Europe has a very strong industrial history, industrial sectors that grow over the last hundreds of years. But we have, as there already said, a very strong fragmented industry. Lots of SMEs, small SMEs, and not so many big companies, especially in the digital economy. And in contrast to large US companies and Chinese companies, we lack really of innovations that are market ready and increase the digital economy of Europe. And so also the data remains siloed, as data readiness of many organizations is not that good that they can share the data with ease. And so there are many companies that also don't even collect data, to be honest, that is reusable later. And this is an issue because only the amount of market value of open data was estimated in 2020 about 184 billion. And this is only the data that was marked as open data and not even talking about the private data. And organizations do not share their data, not only because of technical barriers, but also cultural or intellectual property rights. And so, we have data, we collect data, but we do not share and do not use the data. And another thing is that AI leadership today, at least for the small models, do not correlate so much with intelligence, but with data concentration. As we can see from research that so-called data network effects describe this very good. So the more data you collect, especially as a platform, the better your processes can be made. And and the better the user experience is. Europe also knows that, of course, and what our response is currently is that we have a coordinated effort to increase that in the European economy and to build the so-called sovereign data infrastructures that can be described as a landscape of the data spaces. And there are many European initiatives that are working on that big picture, like the DSSC, what I personally drive also. The IDSA, for example, Gaia-X, and the Eurostack initiative with slightly different foci, of course. But everyone is working on the digital sovereignty of Europe, or what we call it in the past, the strategic autonomy of Europe. And therefore, we have our shared vision that we, as Europe, build a federated, trusted data sharing infrastructure that we call the single European market for data. And therefore, we build the foundational work of interoperability, governance, connectors, and usage control that we develop in the data spaces as reference implementations for technical and organizational constellations to share data. So the structural problem that comes with AI, especially in the vertical level, so sector-specific AI, is that in industrial use cases, those big LLMs usually fail. What was described by the tabular problem, for example, and other problem to really make sense of industrial data, data that is in tables and now I see. Okay, I would need to arrange myself. So one thing is that we lack, this model's lack of high qualitative property data to train themselves, to get trained on using those kind of data or solving those kind of structural problems. And we have also the legal barriers that hinder the organizations to share their data freely, to bring those data into the training data sets for those large language models. Due to the low number of data that can be used for sharing, for training them, it's also not possible for SMEs and also public institutions to train their models to use them as support for business operations. And the third point is that large foreign platforms like OpenAI, etc., dominate the market currently due to the first mover advantage. And so, yeah, Europe has currently a structural problem based on that. And yeah, due to even higher privacy concerns, organizations and people are also, if you would ask them, they will not share the data with OpenAI, but I'm the best example. Everyone is doing this constantly. And so, yeah, we are losing more traction day by day, I would say, because we need those data spaces also to have the data that we need to train the models. So in a nutshell, from my understanding, so the sector-specific AI use is blocked by foremost 3 reasons. So there is unclear data rights and obligations in many cases. So even within the companies, there is not a very good data governance implemented, but especially across the domains. And then we lack currently of mutual trust frameworks. So if you share data, you need to know all the components that are used, all the actors that are in those systems. And so, yeah, Gaia X is working on it and other organizations are working on it, but currently we do not have one international accepted trust framework that basically explains who is talking with whom, let's say, and which components they're using. So when you share the data currently without data space, let's say, you cannot have any proof where your data goes to, who's receiving it, who's also computing, doing computing on it. And so many high-value data in Europe remains completely unused. And the question is then how to build such a sovereign, scalable, and inclusive data foundation that you can then use to enable AI across all those sectors. And basically, this was explained very good already, is data spaces for AI. And we define them usually amongst 4 layers. The data ecosystem layer, where competition is happening amongst the data spaces and all other platforms and individual players. And then within the data space, we differentiate 3 layers. So business applications that can be used inside and outside of the data space, transactions to really transact the data from component to component, and the infrastructure layer we define like as the global data sharing infrastructures, which include all those compute capacity and also the infrastructure that is needed to connect all entities in one data ecosystem. And of course, we are having many initiatives that were already mentioned previously, like Catena X, IDSA, Gaia X, who are working in a very big European ecosystem on making this infrastructure happen in the future. And why we really need it. I skipped now the healthcare as it was discussed intensively. For example, in a manufacturing use case, this is a very, very fragmented sector where we have very small companies of 10 or 20 workers who do usually not collect any data, but they have also the machines which they need to maintain, also increase their effectiveness. I skipped a lot. So, yeah. No, 2 more. Yeah, so in this very fragmented domain, it's highly, it's really needed to share the data, because you can imagine if you have one machine in your company, you rarely get any data that you can use to improve it. But if you connect them with federated learning, for example, across organizations across whole Europe, you get the data points to do that in effect. So, yeah, so in conclusion, for me this logic is built on those 3 layers. So if we can make the data spaces use and include AI and make the data in data space available for AI, we can create a trusted environment in which organizations can share the data without losing the sovereignty with ease. The transactions will happen within the sectors that you can train those small language models. And finally, you create a business layer where you can have the multi-actor AI value creation that increases the economic cake of Europe. Yeah.
Thank you very much. So we are running a bit late, and we have a coffee break before the second session. But we can collect 1 or 2 questions of the floor. If you have any, okay. So take a microphone, please. Is there there is a microphone over there. No. Vas-y, pose-la.
Hello, Kumudit Pereira, Data Protection Officer of the University. Thank you very much for sharing your insight. Kumudit Pereira, Data Protection Officer of the University of Dauphine. What you mentioned is really interesting. My question goes to all of you. What is your take on the digital omnibus, which is going to be published tomorrow? How can we safeguard our European data spaces against the American and Chinese companies which could just flood in?
Joël?
A very technical question, teenage question for Emmanuel. No, but it's another one. To Emmanuel, you told us about the European Health Data Hub, but who is in charge? Who is the orchestrator of this fantastic... wow.
So it's been voted. It's a regulation that has been voted by the Commission.
A pity.
Okay, so I will let each of the speaker give to wrap up something in 1 minute and reply at the same time on the question on the impact of the omnibus text. If you have any idea on this, of course.
Well, I sensed there was a question about protecting data against vis-a-vis, let's say, the American hyperscalers is certainly one, or whoever you might mention, sort of coming from outside of this space. Well, I mean, basically, that's what I see as one of the fundamental reasons why we have the data space governance structures is, for example, to be able to set up a bunch of rules such that anybody taking a part in these data sharing ecosystems need to play by these rules. Now, these parties can be any companies. They can be American companies. They can be Chinese companies. In fact, Huawei is, for example, a partner. Microsoft is a partner. And how can this be? Well, that's due to the basic governance structures. And so if you ask what is really, for example, Gaia X, basically, in some sense, well, it's a bunch of policy rules and an architecture reference model and a trust framework setting up a complex set of rules that says essentially if you want to play in this space, you have to follow these rules. And then insofar as you really do that, you can be an American company, you can be a Chinese company, you can be whatever kind of company. The rules are designed in such a way that, that there's reasonable trust constituted by following those rules. And that's the basic logic of how to deal with that part of your question, I think, coming from the data ecosystems.
So I'm not totally sure I understood your question. You are talking about the omnibus, about and particularly about the pseudonymization, right? Yeah, and there is a big part on pseudonymous data might turn as anonymous data. I mean, this is a very important.
There was already a case law, so it was already in like.
So yeah. I'm not a lawyer, so I don't know how far what is the exact impact? I discussed with some lawyers. It's not that clear for me what is the exact impact of this omnibus thing, and in terms at least for health data, it will. This will be it could be very, very impactful, but it depends really on details on the law that will be voted. So it's hard to comment because basically with the GDPR, almost all personal health data are considered, even when you take out the directly identifying fields, they are considered as pseudonymized data. So it's still sensitive data. So you can access them, but in secret space and so on, which is not the case in the US, for instance. If you de-identify the data, it can be open sourced. So that's a major issue, and particularly for generative AI, because if you take an LLM and if it sees a medical report, even pseudonymized, so with no directly identifying items in it, the LLM becomes sensitive data, you cannot share it, and so on. So if it turns out that pseudonymized data is going to be anonymous, but it's not what it says exactly, but it says it is kind of really weird. It says that pseudonymized data could be anonymized for some person. So it depends on the user. So it's the status of the data will depend on the user that will use the data. That is, so we would have to understand it more carefully. Now, if I have to say one more thing, in more general. So I told you that I think data is, of course, we all say that data is very important, but maybe it's not that politically correct what I'm going to say because we are all talking about AI, but at least in health, I'm totally convinced of what I'm going to say. If we do organize data spaces with health data, high quality, interoperable, and so on, so on, so on, it will be a major impact for public health, first of all, without AI. There are so many things to do without AI. You cannot imagine. It will be a huge impact. Then we can do things with AI. AI on the shelves, not like new things. And then we can do things with new methodologies. But first of all, there are so many things to do without AI.
Thank you, Emmanuel. This is exactly what we are explaining to the industry when they are developing their data space. They should start by developing some relevant use case that bring value, because this is essential for them to be incentivized to verse data in those data spaces. Hubert.
No, I have nothing to add to what Emmanuel has said. That's why we need to have a season 2 of data space, and we should not rush on a very heavy budget data center until we understand which data we are using. Another point I would like to share with every one of you, in the 2 cases where we have now data space to be created in aeronautics and nuclear, this question of using American service cloud provider is simply another challenge, but it is not a crucial challenge. Both Airbus and EDF, they know that they need to have a multi-cloud approach, and they wish that the data intermediary take care of that, respecting the rules they have, especially because they are regulated industry. So I am amazed myself how much attention is paid in France about what we call digital sovereignty, which has almost no translation in Germany, and they only know data sovereignty. So if you make the difference between the two, you have exactly my view. Digital sovereignty is which nationality are the tools you are using. Data sovereignty is, are you mastering the data you are using? Are you in control? I believe we need to switch from digital sovereignty to data sovereignty if we want to progress in this data challenge.
Thank you, Hubert. Tobias.
Yeah, so 3 points from my side that I can add. So first, if we really want to make this happen, what we are talking about, we must increase the data readiness of organizations to be able to share something, of good quality or of a quality we really know. So this is the first point. So organizations do something and be proud of your data if it's in good quality. Because this is also a point where organizations struggle to share if they know their data is of bad quality. So the second thing is we have said many about European and national funding and whatsoever, but for me, any use case that is not for the good, let's say and even this need to get to some point where it's only funded by private money, because only then I believe we can make this thing fly and not to some communist party, let's say, if we only depend on public funding for this. The third thing is the governance and management of those systems. So we in the DSSC developed like a reference model for data spaces, but we really need to understand the value creation mechanisms and the value distribution mechanisms, and to create fair ecosystems and a fair data economy, because otherwise people do not want to take part of it, and organizations. So thank you, everyone. That's from my side.
Yeah, thank you, thank you to the four of you. We'll resume in 20 minutes in this room, so at 15 past 4. In the meantime, we'll have a short coffee break. And as announced, the second roundtable will be more focused on the question of sovereignty. So we have a perfect transition from the conclusion of this section. And also we'll discuss frugality and efficiency of AI system efficiency, both from a technical viewpoint, but also from an economic and ecological viewpoint. If maybe we don't need those very large and very costly model to do a lot of things with AI. So thank you very much, and see you back in this room in 20 minutes.
So please, could you take your seat? Okay, so after the wonderful first session, we are now in the question that some of you take the word. What is sovereign AI? And what are the challenges? So, as we don't have yet the answer, the idea for this roundtable is to have different points of view. What could be sovereign AI for public policy? What could be sovereign AI for the development of all the activity? What is sovereign in the AI and in the software up and down? So to have what is sovereign AI for a French international company? So the idea is to have different point of view, and maybe to answer on some way the question that, as far as I heard, is a Franco-German European meeting, but not here in Berlin. So, in fact, as you can see on my right, you don't have Bruno Sportis. Bruno is in Berlin. But we have a wonderful person from INRIA, and she will be representing Bruno Sportis to present for us, what is sovereign AI for INRIA, INRIA being in charge of sovereignty for the state in different issues. we will have, after Selma, Anastasia Strasenko. She's a co-founder of LEAS, and I will come back after to present her. Then Laurent Lafay, co-founder also, but for DAOX. And last but not least, Claude Lepape-Gardeux, VP Technology Portfolio and Partnership in Schneider Electric. So with these four very interesting persons, I think that after we will have a debate about the different meaning of sovereignty. And first, Selma. Selma has an engineering and PhD background and has developed a path at the intersection of research, software development, and management of technical teams. She spent part of her career in the private sector, holding both technical and managerial roles, before joining INRIA to lead the P16 program. You will know what is it. A strategic initiative dedicated to developing a sovereign and interoperable AI based on open digital commons. She is now Deputy Director of INRIA's AI program, and she contributes to implementing the Institute's strategy in the field of artificial intelligence. So, Selma, the floor is yours.
Can you hear me? Yeah. So I don't have any slides. Hopefully I can keep it engaging and interesting for everyone to follow my speech. It is a pleasure and an honor for me to be with you today on behalf of Bruno, who unfortunately, as Joël said, could not be with us today because he's in Berlin for the Franco-German Summit on Sovereign AI. And it's quite a symbolic moment because it's exactly the subject that we have at hand today. So let me start by thanking Joël for her invitation and her long-standing engagement for sovereignty, regulation, and all her work on the economic foundations of the digital work. One sentence on the purpose of my speech today, it would be to share with you how INRIA is building sovereign AI, not by isolation. It's a very important word that will come throughout the speech, but by ecosystem design, from skills to software commons, from compute to evaluation, from industry partnerships to public policy alignment. So as some of you may know, and as Joël said, since 2018, INRIA has been responsible for coordinating the research component of the National AI Strategy for France. This coordination mandate was renewed in 2024 and extended to include higher education and research in line with the evolution of our partnerships with the universities. So this was really a turning point for INRIA, that was traditionally a research institute, and that is now asked to structure the national effort because AI has become a question of sovereignty and technological autonomy. So the mandate is clear: build a sovereign, competitive, and innovation-driven AI ecosystem for France and Europe, and again, not AI in isolation. So first we have to build a public-private ecosystem rooted in science, connected to industry, and aligned with society. And this is exactly the philosophy of the Agence de Programme. Some of you might have heard about it. The program agency that we built over the past few years at INRIA, an architecture that mirrors the reality of modern AI as a continuum, starting from AI, going to cybersecurity, cloud data infrastructure, high-performance computing, and closely tied to applications, such as healthcare, for example. So the mission of the agency is to work alongside the state to develop a long-term vision and manage national programs involving all stakeholders, academics, universities, and the industrial sector. All our programs address digital sovereignty challenges to strengthen society and industry capacity to transform through digital technology in a constrained world, you all know it, while increasing our economy's competitiveness. So there is no sovereign AI without a systemic approach. And now I will talk to you, or I will walk you through, the key pillars of our strategy. The first pillar is skills, which is the mother of all battles. So every strategy needs to begin with people. And France can rely on a distributed academic backbone that is strengthened by the AI clusters that have the mission to educate, attract, retain talent at scale as a core pillar of France 2030 and the National AI Programme. These hubs embed universities, les grandes écoles, national labs with a clear target, move from 10,000 of trained students each year toward 100,000 annual capacity by 2030, while anchoring research, industry collaboration, and international visibility. And INRIA plays a role in the coordination of AI clusters. The second point when talking about skills is research structuring. On the research side, INRIA co-leads the National Priority Research Program and Equipment on AI with CEA and CNRS. This multi-year 70+ million target program targets scientific foundations, frugal and embedded AI, as well as trustworthy AI, with the purpose of structuring scientific communities and funding frontier research. And last but not least, organizational understanding. And in this matter, we have the Labor AI. Some of you may have heard about it. It's a research action program that is in collaboration with the Labor Ministry that studies AI's impact on work, skills, and social dialogue, connecting researchers with HR functions, unions, and public administrations. So we cannot build sovereign AI if we do not build sovereign skills and if we don't understand how AI reshapes organizations from within. That was the first pillar. Now let us move to a second very important pillar, which is the public-private partnerships in with French industry. And there has been a critical shift in the INRIA innovation and partnership building as of late, as it has been reoriented towards building strategic partnerships with the French actors, primarily with the French actors. France has strong technological actors, such as Dassault Systèmes, Thales, ST Microelectronics, Criteo, Valeo, etc. And with them, INRIA is building bilateral collaborations that root AI in the fabric of national industry. These partnerships enable co-development, technology transfer, and industrial adoption and real-world validation of the models that we are developing. And talking about transfer, another very important pillar is the strengthening of the deep tech pipeline. So this is the mission of the INRIA Startup Studio, which is one among the accelerators and the incubators that we have in our ecosystem. The role of INRIA Startup Studio is to accelerate startups coming directly out of the public research, building initiatives with strong IP strategies, long-term industrial technologies, and with positive national outcomes when acquired or scaled by French industrial leaders. We have an excellent example to share from the INRIA Startup Studio is Pulse Audition that has been acquired by Essilor. So a full French deep tech trajectory from lab to national industrial champion. So a sovereign AI, again, ecosystem needs sovereign startups, not as an afterthought, but really as a strategic pillar. The fourth pillar, it's software infrastructures, and I will be talking about something that is a project that is close to my heart because it's with this project that I rejoined INRIA. So INRIA was the place where I did my PhD, but I came back again at INRIA to lead this project P16, which is the 16th measure of the national strategy for AI. So this strategy builds to, or aims to build digital commons for machine learning and AI, leveraging the success of projects such as scikit-learn, which demonstrated high-quality open source software can have a real impact while originating from public research. So we take this vision a bit further. We try to identify some libraries that are that could have an impact on the industrial world, and we work on their pre-industrialization. And we work in collaboration with Probable, again, maybe a word that rings a bell for some of you. Probable is a spin-off for INRIA. It's a spin-off whose aim is to experiment with a new governance and industrialization model where we develop a set of services, of products that accompany the use of these libraries that stay open source and can be used by everyone, and that ensure that they remain open and accessible, maintainable, and applicable by the industry. So again, for P16 and Probable, the ecosystem thinking is essential. Libraries do not live in isolation. Their success depends on integration with compute platforms, services, and the developer communities. And here I will link naturally with initiatives such as AI Factory France. We have been talking about it just now, which is the next point and the next pillar of this strategy, compute resources. So it will come as a surprise to no one, I hope. AI needs compute, and not compute that is rented at the other side of the world, but compute we design, understand, and control. So this is exactly what we are building with the AI Factory France, led by GenC in close partnership with INRIA, CNRS, CEA, data centers, universities, industry partners, and the public institutions. And AI Factory France is not just an infrastructure, it is a national hub providing access to supercomputers, Jean Zé, Joliot-Curie, Ad Astra, the soon-to-come Alice Lecoq, that will be our upcoming exascale machine, as well as training, technical support, and pre-packaged AI models. So the AI Factory's ambition is to offer a sovereign continuum where compute, data, expertise serve researchers, startups, industry, and the government. And tomorrow we'll have also the need for AI gigafactories, specialized data centers optimized for training large models with energy-efficient architectures. But for now, I unfortunately cannot say more about this matter. The next pillar of our strategy is how we fund projects. And we have to go beyond the classic call for proposals. We cannot build a sovereign AI agenda only with traditional call for projects. We have to implement mission-driven funding with strong and bold goals, with fast decision cycles, agile cycles, and the capacity to stop or to accelerate projects in this fast-paced environment that we all know. So this is exactly the logic of Pionniers de l'IA, or AI Pioneers, the call that INRIA launched in collaboration with BPI France under France 2030, which is an ARPA-style project factory that we are trying to implement. This initiative is specifically designed to support R&D projects that have a disruptive potential, a disruptive aspect to them, and sectorial impact, projects that can contribute to our national and European sovereignty. So sovereign AI requires also the possibility to take some risks in terms of funding disruptive projects. So talking about sectorial applications, because when I was talking about AI Pioneers, I was saying that it had to have sectorial impact. We also, at the INRIA level, align with the priorities of public policy in terms of sectorial applications. Because AI sovereignty would be meaningless if it remains confined to technological bubble. We have to build sovereignty through real-world applications in the sectors where national resilience is at stake. And here we will be taking two examples, the first of which is the defense one. Again, it comes as no surprise to anyone in the current geopolitical circumstances that we all know. So at INRIA, our security defense mission that has been set up in 2020 explicitly supports the Ministry of the Armed Forces tackling critical challenges in cyber defense and cyber resilience, multimodal data processing, trustworthy AI, and multi-agent and robotic systems. All of this in order to address real operational needs by combining INRIA's scientific expertise with defense actors operational demands. The second strategic example that I will give here is health. So in health, federated learning could be seen as a French strength. INRIA works with the APHP, with the Marseille Hospital Network, for example, among others, to build federated infrastructures capable of powering clinical research, diagnostics, and personalized medicine without exposing patient data. And this, I believe, was a subject during the first roundtable. So talking about sensitive data, we can now touch upon the 8th pillar, which is regulation, trust, and evaluation. So we strongly believe that innovation and regulation should not be opposed. This is a false debate. To implement regulation, we need innovation. We need technical systems capable of evaluating AI, its robustness, its risks, its fairness, its environmental impact. This is exactly the purpose of INESIA, the national initiative to build scientific and technological foundations for AI evaluation, launched under the SGDSN, Secrétariat Général de la Défense et de la Sécurité Nationale, and DGE, Direction Générale des Entreprises. And it is not an only regulatory project, it's also a research challenge that is involving the ANSSI, the National Cybersecurity Agency, which brings its expertise on system resilience and threat analysis. It involves, of course, INRIA, which contributes its scientific know-how in AI research, robustness, evaluation, and mathematical modeling. It involves the LNE, which brings to the table its expertise in terms of AI metrology, and then the PEREN, which brings regulatory and normative insight to the table. So we are also working hand in hand with the market surveillance authorities, for example, through a recent strategic partnership with the French Data Protection Authority, the CNIL. The 9th pillar, and that would be the one, we have 10 pillars in total, so just bear with me, we are almost there. So the 9th pillar is about alliances. Sovereignty is not self-sufficiency, it's not working alone without collaborating with anyone. It's also the ability to choose our allies, it's also the ability to negotiate with our partners. And today, Bruno being at Berlin, it's also because France and Germany have decided to work together to advance a joint vision for sovereign AI. So we are not working alone on that. It's by no means a protectionist approach. So in RIA, we have a long-standing partnership with the DFKI, with whom we share a strategic agenda on open, trustworthy European AI. And also this Franco-German momentum is embodied by our collaboration with the Fraunhofer Institute, another pillar of applied research in Germany. And beyond bilateral ties, we also must invest in multilateral frameworks. And this is exactly the role of the Global Partnership on AI, which France co-pilots with Canada and with Japan, with INRIA coordinating the scientific work, and that has now transitioned into a new expertise center working with OECD, global policy guidance, safety norms, and evidence-based regulations. So this matters, all of this matters, because Europe must offer a third part between the surveillance-driven AI model of China and the platform-dominant, attention-seeking AI model of the United States. The last pillar is how we handle cultural issues around AI. We cannot focus only on experts. A sovereign AI requires also a digitally literate society. If citizens do not understand AI, if they feel excluded, if they see it as a black box or some kind of black magic, there will be a backlash on education, on labor, on democracy. So technologists have also the responsibility to explain, to engage, and to make AI approachable for all. Because the societal questions like attention, the impact of AI on learning, misinformation, all of these questions are still coming. We are still seeing the beginning of it. And of course, there is no sovereign AI without societal and social trust. So to conclude, France and Europe face a simple choice. be users of other nations' AI, or be contributors and shapers of the next technological wave. Our French policies, our programs, our partnerships, our research, startups, they all aim at one goal, to make Europe a place where AI is invented, not imported. So thank you all for your attention, and thank you for your commitment, hopefully, to building a European AI that is ambitious, responsible, and sovereign. Thank you.
Thanks a lot, Selma. Big program. So now our next presentation will be from Anastasia Stasenko. She's, I hope I pronounced well. She's co-founder of Playas. She will explain us what is Playas. And she has a background in philosophy research, and she turned to generative AI with a focus on transparency and regulatory compliance. At Playas, she led the development of the first fully copyright-compliant language models and the best small models under 1 billion parameters. She currently leads the AI for Public Good initiative and is part of Station F Female Fellows program. Her work focuses on building sovereign AI infrastructures for Europe. Anastasia, the floor is yours.
Yeah, now it works. Thank you so much for the invitation. Really happy to be here and give a couple of, let's say, smaller plans about what sovereign AI could be. The ones that even a 10-person bootstrap startup could actually put in place. And I think that the pragmatism is also something important when we talk about sovereignty. So just to probably start very quickly about what Playas is. So you already know that we are a very small bootstrap startup based in France, 3 co-founders, still very much fully owned by those co-founders. We created Playas 1.5 years ago with an idea that we actually saw from the use cases that we have been developing for the French government, especially Albert, which kind of became one of the main use cases of the French government and already deployed by almost 10,000 public servants. So what we saw when we were working on that use case before creating Playas is that there was still need for more transparent and for more efficient models. And the real issue with the models which were the open weights models which were available back then and which still constitute the majority of the models available on the market was the data problem. Well, as we often say at Playas, the devil is in the data. So why I'm saying this is that basically the majority, not even even most, the totality of the AI labs are currently, have been pre-training and are currently pre-training on the web archives. Web archives did allow for the generative AI as it is now to exist because of the scale of the available data and because of the fact that we could finally prove that with big amounts of data, lots of compute, we can train models which generalize. So this is great. However, the web archives do contain lots of information which pose issues both in terms of their legal compliance. It is not possible to filter out the copyrighted content out of the web archives. It is not possible to do this at scale and to ensure that if we just take the web archives, there is no copyrighted data, because basically you then need to have a sort of, let's say, already existing corpus of all data that is copyrighted and filter it out against the web archives. It's not possible. So the current situation is that even if you take, for example, the corpus such as FineWeb by Hugging Face, which are open one that you can basically consult, it does still contain copyrighted material, and in Europe, where we do not have fair use, this is an issue. So for us, there was a question of course, the legal compliance, specifically because it was we were creating the company at the same time that the EU Act and the Code of Conduct was forming, and we saw that there was some interesting push for the copyright-aware training. And the second thing is that we really wanted to kind of hack the system a little bit. There must be more data-efficient ways to actually train models which could be good at enterprise settings. The reality of the situation that the enterprises do not speak Reddit, and they do not necessarily need for their use cases to have the cognitive course of the totality of the humanity, but they need models which can work with specific data, with the legalese. They need to know how to comprehend complex PDFs. And all of this is not readily available in the web archives. One of the things that struck me the most in the recent months was the discussion I had with a person from Common Crawl, basically the organization doing this web archives, in who explained to me that as of now, they actually do not crawl PDFs which are bigger than 5 megabytes. Okay, so let's just imagine what it actually means in terms of beautiful data in the PDFs and whether it actually finishes in the models. Some of it does, but most of it doesn't. So basically, we thought, okay, but let's try to see whether it would be possible to have a different approach. The different approach, which would be data-centric, and who says data-centric means actually provenance-based. So we will choose our data sources and ensure that they correspond to the criteria that we fixed for ourselves in the beginning. The criteria that we fixed: permissive licenses only, so basically copyright compliant under the European law, and good quality and pertinent, right? Okay, diverse. Diverse meaning multilingual, legal reasoning, cultural reasoning, so not only conversations. And so this is what we basically managed to do by creating the common corpus, which is, as of today, it's a very cool artifact. It's been used for training over 7 sovereign LLMs. Sovereign meaning the projects which have been developed by the states. For example, Apertus.ai has been partially trained. Apertus.ai is a Swiss model, was partially trained on the common corpus. GPT-NL, the Dutch sovereign model, as well as Salamandra series, which is a sort of Spanish sovereign model series. So, and we trained our small models, and what we actually saw is that you could have a very data-efficient approach, and you can have small models which wouldn't necessarily answer all of the questions that you might possibly have, and this opens some of the questions about the generalist B2C use, but they could be put in production with high efficiency in the enterprise settings, specifically when it comes to the use cases which are more specialized. So this is where we come from. And this is the basis that allows me to actually to come to a little bit of problematization around the understanding of what sovereign AI could be and should be in the nearest future, specifically in Europe. The thing is that the problem today that we are seeing is that when we say sovereign AI, we are actually always thinking about having the analogs of the frontier models, or very big models which would basically more or less replicate what ChatGPT could do at least 6 months ago. ChatGPT still cannot do a lot of things, and this is why, if you believe at least the studies conducted by the organizations such as MIT or many others, the enterprise adoption is still quite low, specifically when it comes to the agentic AI. And so what we are seeing currently interesting, technologically speaking, in the field, is that we really need to take a little step back and ask ourselves, what could be a competitive AI? Competitive AI for the enterprises, and try to understand the sovereignty, at least this is the approach that we would like to take, to understand the sovereign AI as competitive AI. And competitive not only in terms of geopolitical competitiveness, so that during the summits we can say, you know what, we trained the 1 trillion parameter model, look at us, we know how to do things at the frontier, but competitive in the sense that the enterprises in Europe could actually build competitive offering and competitive business models, which would be actually new ones and AI natives, based on the model, which we do think is the product, which could not be replicated by a simple plugin to a frontier model, HIGPT, a Claude, a DeepSeek, and whatever. And here the data spaces and the data do play a huge role. However, data here is not enough. Specifically, raw data is not enough. Because you cannot simply train reasoning models, which do need not to just know the data, to memorize it, but which actually need to follow certain reasoning patterns, which have to be modelized starting from the original data, right? For example, if you have health records, in the health records you have certain information which have been deduced, which have been transformed, and all of those transformations and the reasoning paths are not necessarily contained already in the final databases, right? So this is a problem, because you want your model to actually not only know the data, but to also reason in certain ways, taking this data as a starting point. And this is where what we are trying to develop as of now is basically kind of what Andrei Karpathy, one of the founding members of OpenAI, call cognitive core, which would be basically a very small model trained exclusively on the data pertaining to the use case. However, the amount of this data would be largely augmented through synthetic approaches. So as of now, this approach around synthetic environments, which actually, what does it represent? We actually rebuilt from scratch the environment in which our model, our reasoner, our agent should exist, operate, behave. Think, for example, of recreating Salesforce, or, I don't know, for example, a certain type of legacy software environment, which you actually do not want other people to know. And like ChatGPT, you don't want ChatGPT to actually know your internal products or the products which constitute your competitive advantage better or even at all, right? You do not want OpenAI to be able to propose the services, to propose the inference over this kind of software. So basically what you would like to do is to create the synthetic environment where you would modelize the data and you would produce the data, which kind of like the models follow in different paths, taking the decisions, etc., etc. And then you train your small model on this. We have done this already, and we proved that this kind of things are technologically possible. This was a very cool experiment. We really had fun doing it. We trained two models, a 50 million and 300 million parameter model. Just for information, it's twice smaller than GPT-2. And basically, those models were trained on the cognitive core of Wikipedia. You know, like the wiki admins, they have selected 50,000 of the most important articles of knowledge for the humanity. So we trained our models on this data that we have augmented synthetically so that it makes over 200 billion tokens, which is actually quite small. And our models achieve the performances on the benchmarks, the reasoning benchmarks, such as MMLU, JSM, 8K, which are the industry standard benchmarks, specifically for math reasoning, for example, which the models which have been trained on over 10 trillion tokens do not achieve. So it means that you can have the performance associated with very small models, which could be done for the competitiveness in the specific use cases. So basically, for us as of now, and I do truly think that those are the questions to ask ourselves for the entire AI field. Can actually the sovereignty be more of the way of competitive models which are very specialized and which could actually allow for more decentralized and for more value creation in many industries outside of basically just a couple of platforms or a couple of value holders, which would be definitely the AI labs. So those are the directions that we are trying to pursue, believing that there's still lots to do in terms of the model trainings, and there is definitely a future for the agentic approach, which would be based on small language models, specialized in very let's say in very extensive ways. I'm not talking about fine-tuning a couple of examples. And this could constitute for wider industries as well as for big enterprises and specifically for the verticals, the real competitive advantage, which would finally make them accept that, yes, sovereign AI is better than a generic API from OpenAI. Thank you.
Thank you very much. One sentence is very interesting. Sovereign had to be competitive. So, next presentation, Laurent Lafay is co-CEO of DAWEX, and he founded DAWEX in 2015 with Fabrice Tocco. And now DAWEX is yet the leader in data exchange solution for distributing or sharing data products with confidence while ensuring security, traceability, and compliance with data regulation. He is for sure a French entrepreneur, and he has recognized experience in the field of data economics and regularly advised decision makers on the creation of ecosystems and data space, as well as on issues related to data circulation, from data trading to the development of corporate data hubs, industrial data hubs, and data marketplace. So Laurent will explain us how is it easy to obtain sovereign AI with an idea, and he proposed a foundation for sovereign AI in Europe with traceability of data and software dependencies. Laurent, the floor is yours.
Thank you very much for the invitation, Joël and Éric. It was always a pleasure to be here, so thank you. So today, I'm not here to give you a product pitch. I would like to use my very practical point of view to talk about the topic of the day. My co-CEO is also in Berlin today, and the day of sovereignty and digital sovereignty. So at European level, the conversation is very present. The recent report by Enrico Letta and Mario Draghi on the future of Europe competitiveness both say in different words, if Europe wants to stay in the game, it must invest massively in the whole AI value chain, from network and cloud to data to compute to skills. What I would like to show in these is that these big macroeconomics arguments meet a very concrete question. Can we demonstrate end-to-end what our AI system really depends on? in terms of data and software. And I will structure my talk with 3 parts. First, what I mean about sovereign AI. Second, why sovereignty depends on contractual and technical traceability of data flows, and also about 100 or 1,000 of open source software dependency in the cloud data AI stack. And third, how we can measure and steer this dependency. So the word sovereignty is everywhere today: energy sovereignty, industrial sovereignty, digital sovereignty, and now AI sovereignty. Instead of treating it as a slogan, let me offer a practical definition. So sovereign AI, in my view, means 3 things. We understand and control our critical dependency. We know where the data come from, which infrastructure and which software components the system uses, which model and external services are really indispensable. Second, we can explain, audit, and if necessary, contest what the AI is doing. This is very close to what the AI Act is asking: proper risk management, documentation, and auditability for high-risk AI system. And third, we can choose our dependency instead of suffering them. We can choose who we cooperate with, on which data, under which rules and governance. The Leta report on the single market insists that Europe needs new investment in digital infrastructure, including data spaces. My main thesis today is we will not get sovereign AI only by funding more models or more GPUs. The central question is, can we prove at any time which data and which software our AI actually relies on, under which condition, and with which systemic dependency? And this takes us directly to the idea of traceability. I would like to separate 2 layers which are often discussed apart, but for AI, they really belong together. First, traceability of data. And second, traceability of open source software supply chain. So for the first, data traceability, I would say no traceability without contracts. When we say data traceability, many people think about log, metadata, data lineage, tools. They are necessary, but they are not enough when we talk about sovereignty, liability, or compliance. From the point of view of a regulator or even a judge, the core questions are more legal and economic. Who provided which data, under which contract, which access policies, which allowed purposes? How are these constraints propagated in the chain when different data sets are combined, enriched, repackaged, and used to train or retrain models? In other words, there is no credible data traceability without explicit contractualization of access and use. In a data space or data ecosystem, one AI system will typically use internal data, data from other companies, data from public body or regulator. Each of these sources come with a contract or policy. It could be sectoral limitation, geographical limitation, reuse prohibition, data protection rules, trade secret clauses, and so on. As long as all these lives on only in human-readable document, PDF, general terms and condition policy document, traceability in practice is weak. No one can say in real time whether a given model still respects all conditions attached to each data flow. This is where we are living, I believe, a critical transition, and where at DAWEX we try to contribute. We are driving a critical transition, moving from human-readable specification to precise, automation-ready, machine-readable specification. Concretely, this means taking contracts, term of use, internal policy, reference framework, modeling them, and turning them into machine-interpretable policies that data exchanges and data spaces can apply automatically. Once every data flow is linked to a machine-readable policy, and every use of data by a AI pipeline leaves a trace linked to that policy, then we can start to answer in a serious way questions like, why was this model trained in full respect of the condition attached to each data source? Can we prove that no data was used outside of its contractual perimeter? What happens if one data provider withdraws consent or if the law changes? So sovereign AI is a strong science, requires visibility to tool the legal and technical traceability of data coming from many sources and many providers. This is actually very consistent with the European idea of common data spaces, an architecture where governance and usage rights are at the core of the design, not afterthought. Second, software traceability. So it's the second layer in the software supply chain. A modern AI system runs on cloud stack, a data stack, and an AI stack. Each of these layers use hundreds or thousands of open source components. If we speak honestly about sovereignty, we must also ask very basic question here. Which open source component does this AI system release depend on? Where are these components developed and maintained? Which community, which countries, which firm have an interest in investing in these bricks? Where are our critical points of dependency in this ecosystem? For AI, we need to go further. We need a full software lineage for AI system. Just as we need a lineage for data, we need a lineage for code. To know which code, which open source communities, which country our AI system depends on. This is very important for security, of course, but also for industrial policy. If Europe wants, as Draghi suggests, to close in its competitiveness gap in digital technology, and if we take the later ideas of fifth freedom for research, innovation, and data seriously, then we must decide where is the open source stack we want to invest, not only where to fund new startups or new models. If we combine these two dimensions, then trust in AI decision no longer depends only on model explainability. It depends on two demonstrations at the same time: data traceability, which data sources, which contract and usage policy, and how these policies were respected all along the chain despite many suppliers. And second, software traceability, which component, which open source community, which country, etc. And again, the key is the same, moving from human-readable description to machine-readable specification for both data contract and software description, so that this traceability becomes automatable, auditable, and enforceable. Let me turn to a point that I think is particularly interesting for economists and computer scientists. How do we measure this dependency and how do we steer them? At the end of the day, the question of AI sovereignty is close to a classic economic intuition. We can only control what we can measure. On this front, the new French initiative of the Digital Resilience Index, the Indice de Résilience Numérique, IRN in French, is worth a look. The IRN, launched by an alliance including RTE, Docapos, Ascent Partners, and the think tank Digital New Deals, aim to measure the digital dependencies of organizations at about software, data, infrastructure, technological assets, internal skills, governance, and resilience to shocks. It's designed not as a commercial product, but as a reference index with a scientific committee, and from 2026, it should be available as a common standard that European companies can use to map their dependency and their religions. What do I mention this in in a session on sovereign AI, because I think it shows a change of phase. We are not only saying we need more sovereignty. We are starting to measure dependencies precisely, to map them, and to use them as steering tools in boards and in risk committees. For AI, I believe we need some similar very explicitly. Metrics for data dependency, what share of our critical data depends on non-European actors, for instance. What substitution scenario do we have if access is cut or restricted? Metric for software dependence, which non-substitutable components are in our AI pipelines? Where are the communities that maintain them? How exposed are we to unilateral changes in license or governance? And metrics for institutional dependence, to which standard contractual framework and jurisdiction are our data and AI governance schemes effectively tied? My simple point is, if we accept with Letta and Draghi that Europe must invest massively in AI, then part of this investment must go into what I could call the plumbing of sovereignty, data spaces and data exchange infrastructure, tools for data and software traceabilities, metrics and indices for digital dependency and resilience. Data space are, from this perspective, observation points, because they see the data flows, the contracts, the policies, and lever for actions, because they can implement machine-readable policies, link data flows to AI Act's requirements, and integrate resilience metric in the infrastructure itself. Let me close with 3 messages. First message, sovereign AI is not only a technology problem, it's an institution architecture problem. It depends on how we define right of access to data, how we write and apply contract and usage policies, how we govern data spaces, how we manage software and open source dependencies. Second message, traceability is at the heart of AI sovereignty. Traceability of data flow based on contract and policies, traceability of the software supply chain, so that we really know which code, which communities, and which country our AI system depends on. And third message, we need indicators and investment at the right level. Indicators of dependence and resilience, and large-scale investments, as Letta and Draghi recommend, but directed also to these invisible layers, data governance, data space infrastructure, and traceability and auditing tooling. As an industrial actor at DAWEX, we work on a small part of this puzzle, the infrastructure for data exchanges and data spaces, but clearly, academic research in economics, in computer science, in law is essential to formalize this notion of dependence and resilience, to design incentive and governance models that work in practice, and to help steer public and private investment toward the right links in the AI value chain. If we manage to build this dialogue between macro vision, diagnostic of resilience, and concrete infrastructure, then maybe in few years we will speak less about sovereign AI as a slogan and more about it as simply the normal way we build and run AI in Europe. Thank you very much.
Thank you very much. Last but not least, Claude Lepape-Gardeux, VP Technology Portfolio and Partnership at Schneider Electric. Claude will tell us how data and artificial intelligence is useful for energy management. Let me introduce him first. Claude is in Schneider Electric, coordinating the evaluation of new technologies, the recognition of technical experts, and the management of research projects and partnerships in the data and artificial intelligence domain. He received a PhD in computer science from Université Paris 11. At that time, it was numbers. And a management degree from Collège des Ingénieurs. He was successfully postdoctoral student at Stanford University, consultant and software developers at ELOG SA, senior researcher at Bouygues SA, and R&D team leader at Bouygues Telecom and ELOG SA. He contributed to several European research projects and to development of many software tools and applications in various domains, chemical mixture, inventory, manufacturing, scheduling, and so forth. He's member of the Scientific Advisory Board of Institut Mines Telecom and of the French National Academy of Technology. So, Claude, the floor is yours.
Thank you. When I received the invitation from Joël, I first thought, of sovereignty in geopolitical terms and started to think that way and discovered it was a little awkward in Schneider Electric because Schneider Electric, of course, it's a French company, but it's also a multinational company. We have activities everywhere in the world, and being responsible for the identification of experts in the data and AI domain, I'm well placed to tell you that we have quite a number in Europe, in several European countries, quite a number in America, quite a number in China, quite a number in India, and also some in other countries. So I thought really that even though there are some frontiers between countries in terms of competencies and capacity to build our own AI system to support our customers, this was not really that was the main difficulty. So I decided to take more a sectorial approach, and here we will see that very quickly we see that the frontier might be not only between countries, but between us and our customers, between us and our partners, between us and our suppliers. So just to give you an idea of our energy management solution business, what does it consist about? It consists in helping our customer, we say making the most of their energy, which might mean several things, which might mean first, identify cases where they are not efficient in their use of their energy. So when there are waste and you want to avoid this waste. And of course, using AI to do that by having some data from the past and some data from other sites and comparing to what happened on this site today, you may be able to say, well, this is weird, you're consuming 40% more than what we would expect. It means also helping them to optimize. And in optimization, here comes one big difficulty, that people don't use energy for the sake of using energy. They use energy to be warm in a building. They use energy to produce things in a factory. They use energy to make some data centers run, bringing services to a lot of people everywhere, and so on and so on. And so when you come into that, you immediately interfere with the particular activity of the customer. And this might be a difficulty when it comes to sharing data. One very simple example, a company producing steel, for example, would not like to give a lot of information about their production and even about the energy used to make this production. Data that is very difficult to share. It might mean also helping to move from one type of energy to the other. So that might be, replacing a gas oven by an electric oven and learning how to work with this electric oven in cases where electric ovens for particular type of application have not been here for a long time, and so we don't really know how to deal with it and manage it properly. Finally, we have in the energy sector very big evolutions that have been coming. For electricity, we used to have, a big producer of electricity, and then this goes to a transmission network, a distribution network, and then you have the final user, whether it's a company or a family, using the electricity. But nowadays, with all the new ways of producing cleaner energy, solar panels, wind turbines, and so on, we have producers all over the place. And these producers, they may use this energy for themselves, they may sell it. They may want to add some energy storage system because at some point they produce more than they need, and so they want to keep it rather than sell it to the grid at low price, and so on and so on. And so we are also making application with respect to that. So to do that, well, we are making some application that very often first require to make some forecast. If I want to manage well the electricity I will be producing tomorrow, I need to know how much will be produced. I need to know also how much will be consumed for my activity. I need to know what is going to be the price of the electricity I can buy on the market. And all these things are not always well known, and so you need to make forecasts with respect to that. And then you need to optimize, and so you may use some standard optimization method, but very often there is so much uncertainty that indeed having examples from the past and trying to learn from what happened in the past is a good way for making the good choice. And here we see the AI and machine learning, reinforcement learning coming again. And you may also wonder how to dimension your installation. Let's say I'm a small business. I want to put some solar panels on my roof because I believe it would be good. How much shall I buy? Shall I buy some batteries? How much shall I buy? What is good? And this with two points of view. One which would be financial. How am I going to make the best rate of return on an investment I'm making? But it can also be environmental. Is it indeed the case that my installation will be good for the environment? And it's not always obvious. I always like to remind that people think, that putting solar panels is good because solar energy does not create any CO2, but you had to manufacture the solar panel, you had to bring them on place and so on. And here you generate CO2 when you do that. It's the same thing when you isolate a house. If you isolate a larger house, don't forget that the product you're putting to isolate your house, they have to be manufactured and so on, and so CO2 was generated for doing that sort of thing. So our customers also want to have help, and here again, every case is a little bit different, so having data about past experiences is very useful in order to make some evaluation of the potential and what should be done. So this being said, so we have been making several studies related to some of the solution we sell and also some solution sold by some partners to really evaluate, not only the financial aspect, but all the environmental aspect with respect to that. And we have been using life cycle analysis for a while to evaluate that, including the carbon that is generated to manufacture all the elements of the solution, but also the carbon that is used to manage this solution. And this brings us to the AI that's running all the time and the carbon impact of having this AI running in the data centers or running in-house and so on and so on. So we've been making such studies. Once we look at this overall business and the evaluation of what this does, we see immediately several things. We depend on a lot of data on our customers. We need to know things about their energy production, their energy consumption, if they have some energy storage, what is the evolution of the amount of energy that is stored, whether it's in battery or it's in terms of hot water or whatever. To help them, we need to know what it's used for, to see if, a little increase in the bill of energy, maybe it allows, to manufacture more products that I really need to sell. So is it better to increase the speed of my line, even though it costs energy, or shall I decrease it and use less energy and go more slowly? And all these are compromises related to their business. We need to know if we are really looking at the environment, are all these activities, are they creating carbon emissions? Are they using water or whatever? And all of this is very important. And of course, all this data is something that is really proprietary to our customers. I mentioned the case of a plant who have reason to keep this data secret. If you even think of a house, if you start thinking about when is a boiler making hot water for the shower working, well, it tells you think about when people take their shower, so people might not always be happy to share this data. So everything is like this for customer data. But we also need data from our suppliers. If we buy solar panels to install a system on one of our customer sites, what has been the carbon intensity of producing the solar panels? We need to do that. If we use electricity, of course, that we buy to the local operator, what is the carbon intensity of this electricity, depending on time and so on? We use some digital services in order to make all of this function. This goes to data centers, for example. What is the carbon intensity of what I do in the data center, depending on the time? Am I sure that it goes to a data center that is installed in Europe, or does it go anywhere, and so on? I would need to know that. And here again, it's data that maybe by default they don't want to share. So this is where really we see the problem of sovereignty, in the sense that of course each actor, is the owner of its data, but at the same time, if you want to have good behaviors emerging, both financially and environmentally, you need at some point this data to move around and be used. So this is where the relationship with data spaces is of course coming, because it offers a way to let each owner of the data, being the owner of the data, to make contracts about how this data will be transmitted, to put in place some mechanisms for calling this data that are going to be as safe as possible, and so on. And this is where we have been getting interested in that, in possibly bringing a solution to this sovereignty problem that we have, to make sure we get the data from all of our partners. Just to give you an idea, we have been engaging in two recent examples. Sorry, I need my notes to be able to tell you that. In the context of Data Spaces Initiative, so one is something that was already mentioned, which is with Valeo and Dawex on making a test on related to manufacturing, and we are also in what is called Energy Data X, working some tests on exchanging data for managing well energy flexibility with 4 German TSOs. Just to conclude, in the end, I discussed with people working on this project in Schneider Electric, and they really said something I like. They say, well, we used to think of the problem as a problem of data interoperability, but more and more it becomes a problem of having a functioning data economy that allows to make the business and also to make the progress that we want, in our case, on environmental matters. Thank you.
Okay, thank you very much for that full, fascinating and very exciting perspective presentation. Now, I don't know who have questions about one of more than one. Can you present?
Okay, so thanks a lot for the presentation. It was the whole presentation. It was really interesting. I do have a question. So Anastasia, you talk about competitive AI. So my question is,
can you present yourself, please?
Of course. My name is Frederic Vincent. Do you know? Okay. Okay. So my name is Frederic. And do I need to present myself more? Okay, so I've got my background. I've got an engineering background. I did some research in astrophysics during 10 years, including 5 years for the University of California. Then I worked for ENERCOP, which is a provider of renewable energy, working on building issues. And for the last 2 years, I reconverted myself in data science, doing some training with data scientists, an organism you may know, data science, data engineering, and data governance. So, so my question is, what will be the metrics for a competitive AI? Because I got a recent example. We know we have the basic metrics like accuracy, precision, and so on. But this week, like yesterday or a couple of days before, I saw some recent studies showing that the current AI, like ChatGPT, Claude, they're completely wrong when they are asked to give their sources. So basically, 2 answers out of 3 are wrong. So they're basically, so it's a typical example of hallucination, you know, because AIs, they are probabilistic models, so they have numerical hallucination because the answer they give is the most probable answer. And we know that the most probable answer may not be true. So my question is, what will be the metrics in the current context to say, okay, this AI is pretty competitive or not?
I allow myself to answer in 2 parts. The first part of competitiveness, and specifically for the future, is the scalability. And the scalability means the amount of energy resources that we would need to deploy the models. As of now, this doesn't seem as a very big issue because we basically use very big models to generate answers from time to time to the questions, what is the capital of France, okay? Well, of course, I'm being very sarcastic, but you get the point. We're still not in the production mode, which would actually prove that this is the new industrial revolution, right? So the scalability and the efficiency of the models and the AI systems based on them is one of the very important criteria. So this is the first part. The second part is about the metrics, which would be more, let's say, related to the quality or the quality of the outputs. So here there are also 2 things. First and foremost, we need to a little bit rethink of how we work with the evaluation. The evaluation in the GI world specifically because those systems do not have specifications. They are not actually they are not built using this, let's say, former frameworks for software, but we can still inject into them some verifiability, and it's not true anymore that those are only stochastic parrots. They are trained on reasoning data, they are trained with reinforcement learning algorithms, and we can achieve verifiability. However, in terms of evaluation, there is a real question on both industry benchmarks. So basically, what does it mean for a model to be good in telecom industry? It's not a trivial question. As of now, we do not have even single one widely accepted benchmark for telecom. There is a group working on that, and for example, Orange is a part of it, so there are some efforts deployed into it. But we do not have a benchmark which would say, this is a model which can be actually deployed in the telecom use cases. We do not have this, right? And the actual telecom industry has specific data formats, specific data ontology, specific also requirements, etc. We were talking about the nuclear industry. Well, I mean, there is nothing, right? So there are the question of both industry benchmarks, okay, which would actually allow for the evaluation of the models, at least when it comes to the first selection of the off-shelf solutions, and this is where the most advanced actors are currently going towards, is the creation of use case specific evaluations with both implication of the enterprise company experts. And this is why companies such as Mercor or Scale AI actually gain so much money, because they can actually provide to the AI labs the human experts, which can create the evaluations, which are difficult exercises for the models to work with, okay? And basically, the companies such as JP Morgan, which are quite advanced in their AI strategy, they have this human in the loop approach, right? But you also would need to have not only human in the loop, but also some scalable way of creating these evaluations, creating this metrics. And so here comes the synthetic data. So I would say that what worked in previous ML environments, basically, okay, we have F1, we have this. Okay, it doesn't really work. But we can have, for the truly competitive AI on the industry or even on enterprise level, what we need to have is the standardization of approaches towards what evaluation is, how it is created, and at least on the main industries level, what could be the golden standards for the AI that can be put in production.
Other question? Oui. Vous allez avoir un micro.
Well, thank you to all of you. Jan Trudel, I'm Canadian, and well, about the sovereignty of data, we still have a problem on our side, let's say. And when you speak about the quantity of data, that question is for Anastasia. When you speak about the quantity, there's so much you can do with the synthetic data. What do you plan to do when let's say we're talking about nuclear? What can we do to find that data? What can we do with the synth data? And what can we do to go further with it?
Yeah, so for basically all of the, what we envision now, okay, so and this is to be tested, of course, I don't want to, to put a bad spell on our efforts, but, so what we are testing is the following approach, having a seed corpus, the initial corpus, which both consist of diverse, I insist on the word diverse original data, which we believe to represent quite in quite good ways the reality of the use case. For example, for nuclear, this would be definitely all the standards which are openly available, right? This is not an issue. Internal processes, even if it's small amount of documents, but we need them. We need to work on the golden seed corpus, okay? So, for example, it couldn't be not that big. For example, for the synth, the corpus that we published, it was 50,000 Wikipedia articles. That's not a lot, right? It's so, and then what we do is that we create the we create the exercises, basically creating lots of. Well, we will publish a technical report on this, but we basically create queries over the seeds, then we back translate them. Well, so basically the idea is to create lots of exercises, not just like generate synthetic out of nothing or just based on one seed chunk example, but actually create lots of different situations of how this data could be used. So we, for example, we simulate RUG, we simulate multi-turn, we simulate, for example, completely adversarial tasks, etc., etc. And so this way we can actually preserve the diversity in the synthetic data, so to avoid the model collapse, because this was the one of the main always criticism, no, but there will be model collapse and whatever. Everything will be yellow as in OpenAI, Ghibli images. Okay, so the idea is to preserve the diversity of the data. So you cannot escape two things. The first one is that you actually need to be super data aware. You need to have data strategy and data governance for your use cases. You cannot escape this. And the issue is actually here. In most situations, we are not data aware. This is the first part. The second part, if we manage to achieve this, we need to have methodology which is scalable for synthetic data generation. Place approach is one of this, at least like we proved it to be one. But it needs to be scaled. It needs to be applied to different data types, and it needs to be tested. So you need two of this, and then you need to have some compute, and for synthetic you would need lots of compute.
Maybe I can share my experience at the beginning of DAWEX. We tried to understand in the US if data marketplace and data spaces could be the market, because you know when we are talking about data, we are talking about the US because all the stack about how to treat data. Not all, because probable is a European and French initiative, but mainly the initiative about how to process the data are coming from the US. And in the US, at that time, 10 years ago, it was very different because there was a lot of data brokers for personal data, but also data aggregators for financial data or alternative data for the stock market and financial hedge funds institution. So the question of creating trusted third party, like in Europe about data spaces, it was nonsense, because a trusted third party, it was big tech. Were the trusted third party, so there was no problem about how to create a trust. So that's why we push a lot in Europe the question of if in Europe we don't have this big trusted third party, we have to create spaces, or not the right, it's a complex word, data spaces, but territories, trusted third party territories where we can exchange data for different verticals, and of course private data coming from the industry, coming from companies with trusted third party. And that's why 5 years ago in Europe, the European Commission pushed a lot, new regulation, Data Governance Act, to create the framework about the data intermediation service provider. It's a trusted third party to exchange data. So the ambition, maybe in the coming years, it's to create this kind of spaces in Europe, and not only in Europe, because China decided last year to launch 100 initiatives of data spaces in China. So that's why we promote the concept of data spaces outside of Europe, in Japan, in South Korea, in Australia, and even if in North America for the manufacturing in the US, because we create all the framework, technical framework, regulation framework, and now thanks to the work with GaiaX and Dauphine, we create also the economic framework to build this kind of trusted third party.
Thank you. Do we have another question? It seems that it's enough for today, maybe. Anyway, concerning what happens, thank you really very much. It was very interesting, I think. And Éric, if you want to conclude.
Well, first of all, thank you very much to all the speakers for having accepted our invitation. Thanks a lot for sharing with us your expertise and your experience. This is not the last conference on data sharing, on AI, on sovereign AI. There are too much, but we'll organize some other event probably in the next few months, years. And thanks to the audience for having supported this cold, quite cold environment tonight. We will continue to organize events around those issues. As you have understood, we are working on this in cooperation with a lot of the stakeholders around the table. So probably we'll have other events, and we'll have another event next week organized in the context of the Axe Institute which is a project linked to the chair. It's an institute is for applied computational social science, and we'll organize a half-day conference on the 26th of November in the morning, and it will be about LLM development and application in different contexts, with both researcher in computer science and in AI, and researcher in finance, in audiovisual studies, or etc., etc. So using LLMs to analyze large corpuses. So thank you very much, and have a nice evening, and see you probably in a forthcoming future. And thank you also to the students who stayed long and attended the conference over there as well. One of the initiatives that was mentioned by Selma was the support of INRIA to the development of programs around AI. We have students from the AI and Society program that has been launched in this context by PSL, and we have also students from the master CEREMADE, who are also studying AI and data science applied to social issues and economic issues. So thanks a lot, and of course also PhD students. Thanks a lot for having attended the conference, and see you soon. Bye-bye.